Section 23 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit librivox.org. Recording by Giordano. Mars and its Canals by Percival Lowell. Chapter 21. Carets on the borders of the Great Diaphragm. Functionally related to the canal system, and yet in look and location contrasted with its other details, is a further set of markings, detected by me in 1894, and re-seen at subsequent oppositions since, along the north border of the southern seas. They lie upon what used to be thought the continental coastline, the fringing edge of that almost continuous band of shading that belts the Martian globe throughout the southern subtropic zone, and called by Schiaparelli the Great Diaphragm. The terrain lent itself to the appellative, forming, as it does, a dark dividing strip of country between the brilliant reddish ochre hemisphere on the north and the half-toned islands to the south of it. By Schiaparelli it was thought to be one long Mediterranean, and though its marine character is now disproved, that it lies lower than the bright ochre regions is likely. To this difference of level is probably due the peculiar phenomenon which there manifested itself to careful scrutiny in 1894, for it was there only that it occurred. The phenomenon in question consisted of nicks in the coastline, a triangular shape and filled with shading. They occurred at intervals along it, and were of the general form of carets, such marks as one makes in checking items down a list. Their position was always where a canal debouched from the diaphragm upon its career across the open continent. The canal itself was by no means necessarily visible. On the contrary, at first it was usually absent. Such was the case with those marking the departure points of the Physon and Euphrates, and of the Amynthus and Lethus, which appeared, without being well defined, from the moment the planet came to be scanned. One by one these carets stood out to view, punctuating the points where canals later were to show, or terminating those that already existed. Strung thus with them at intervals was the whole coastline of the diaphragm, beginning with the Mare Icarium, and stretching round through the Mare Tyrrhenium, Mare Cimmerium, Mare Cyrenum, and Mare Erythræum, to the Mare Icarium again. As the planet got nearer to the earth, their peculiar shape began to define itself, and it was again in the case of those giving origin to the Physon and Euphrates that the recognition came first. What had happened earlier simply as a spot now stood out as two triangular notches, indenting the coast and giving exit at their apices, the eastern one to the Physon, western to the Euphrates. These were the things, then, that had constituted the Portus Sigeus of Schiaparelli. Commonly the carets lie at the bottom of well-marked bays, as, for example, those terminating the Syrtis Minor and the Sinus Titanum. But frequently they are placed in the very midst of a long and otherwise unaccented coast, as is the case in mid-course of the Mare Cimmerium and the Mare Cyrenum. Yet in no instance is the thing unassociated with a canal. In every case one or more canals leave the caret for their long traverse down the disk. This is not their only canal connection. When the canals in the dark regions came to be discovered, each of them was found by me, as nearly as difficult observations would permit, to be associated with the caret upon its other side. Thus the lacing of the Mare Cimmerium and Cyrenum used them as its reeving points. Similarly those at the mouths of the Physon and Euphrates did duty likewise to the Masullus and the Ion. In such manner the carets stood in dual relation to canals, subserving a purpose to the light region canals on the one hand, and to the dark regions on the other. In a way the caret then holds the same position towards the canals that do the spots in the light or dark regions. Like them, it is a canal distribution point. Unlike them, however, in shape it is triangular instead of round, and we are piqued to inquire to what cause it can owe its different contour. The answer seems to lie in the character of the locality, not simply in its complexion, for the spots in both the northern and the southern dark patches are as circular as though standing in the light, whether they lie in the center or upon the edges of them. The edges of the northern patches, however, and the other sides of the southern ones, do not present the clear-cut character of the northern coast of the diaphragm. Where they seem to be definitely bounded, they are so by darker canals. This hints that their contours are not defined by antithesis of level, while that of the northern coast of the great diaphragm is. Difference of altitude is then concerned in their constitution. The canal system here falls to a lower level, and these triangular spots instead of round ones are the result. Topographic only, such explanation leads the way to a more teleologic one, and serves even on first acquaintance to stir curiosity to some satisfying cause. Suggestive in several ways for its resemblance to the Carets is another detail not far distant from the Portus Sagaei, the twin-forked sebaeous sinus. Curiously enough, this feature of Mars, which has been well known and recognized ever since the eagle-eyed Dawes detected it more than 40 years ago, proves to be a sort of connecting link between the main markings and the details of more modern detection. The twin-forked sebaeous sinus, as its name implies, is of the form of a double bay, was considered to be one in fact so long as the Morai were held to be seas. It straddles the point of land which, called the Fastigium Aeron, has been taken for the Greenwich of Martian longitudes. Each bay, not in truth a bay at all, indents the ochre in an acute triangle, from the tip of which many canals proceed like the rays of a fan from a holding hand. Both tips are darker than the main body of the dark mare from which they proceed. They thus recall in general character the Carets. They further reproduce specifically the Portus Sagaei, for they give origin to two doubles, the Gihon and the Hiddekel, in exactly the same manner that the two nicks of the Portus Sagaei do to the Ephyson and the Euphrates. Nor are their tips much further apart than those of the Portus, 5 degrees measuring the spread of the one, and 4 degrees that of the other respectively. The reason for their earlier discovery lying in their greater size. They thus perform the same office as the Portus Sagaeus, are quite comparable to it in width, and differ in shape only as a larger and more acute triangle differs from a smaller and blunter one. Undreamt of by Dawes, and unheeded since, they were the first hint to the world of the duality which forms so strangely pervasive a feature of the canal system of the planet. Thus the Carets stand connected with the canals quite as intimately as the Oases, but in a significantly different manner. For, in addition to their intermediary standing between the light regions and the dark, their relation to the doubles is peculiar. An instance is offered by the double Euphrates, and another by the Ganges. The Euphrates, as we saw in Chapter 18, leaves the Portus Sagaei at the south, one line leaving each Caret centrally, so that each Caret is concerned only with its own line and has no connection with its fellow. At their northern ends both lines have similarly each its own Lucus Ismenius. The like seems to be true of the Ganges. Similarly the twin Titan have each its own. Such twin duty in the matter of doubles seems to be the rule with the Carets, even more so than with the Oasis, and this is probably from the fact that the coastline is of more limited extent than the interior. Although the Carets offer to our inspection glosses in finer print upon the general text of the canals, thought upon what they show takes us a step farther toward the solution of the strange riddle of this other world, a riddle which he who runs may not read, still less scout, and which only reasoning, without prejudice or partiality, can unravel. End of section 23. Recording by Greg Giordano, Newport Richey, Florida.
Section 24 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit librivox.org. Recording by Availle in May 2020. Mars and its Canals by Percival Lowell. Chapter 22. The Canals Photographed. Photography holds today a place of publicity in the exposition of the stars. Directed by Draper to the heavens 34 years ago, the camera recorded then the first picture ever taken of the moon. From this initial peering into celestial matters, practice has progressed until now the dry plate constitutes one of the most formidable engines in astronomic research. Not most effectively, however, in the field which might have been predicted. Beautiful as the lunar presentment was, as a presentiment of what was coming, it pointed astray. For it is not in lunar portrayal, superbly as its crater walls in Crescent Chiaroscuro, or its crags that cast their tapering shadows athwart the dial of its planes stand out in the latest photographs of our satellite, that the camera's greatest service has since been done. Impressive as they are, these pictorial triumphs are chiefly popular and appeal on their face to layman and scientist alike. Not in the nearest to us of the orbs of heaven, but in the most remote has celestial photography's most prolific field been found to lie. Its province has proved preeminently the stars, especially the farthest off, and that stardust, the nebulae, from out of which the stars are made. Reason for this explains at once its efficiency and its limitations. Its rival, of course, is the eye. It is as regards the eye that its comparative merits or demerits stand to be judged. Now, thus viewed, its superiority in one respect is unquestionable. It simply states facts. But though it cannot misinform, it can color its facts by giving undue prominence to the effect of some rays and suppressing the evidence of others, so that its testimony is not, it must be remembered, always in accord with that of human vision. Speaking broadly, however, it is so little complicated a machine as to register its results with more precision than the retina. The evidence of the camera has thus one important advantage over other astronomic documents: it is impersonally trustworthy in what it states. Bias it has none, and its mistakes are few. Imperfections indeed affect it, but they are of purely physical occasion, and may be eliminated or accounted for as well by another as by the photographer himself. In trustworthiness, then, so far as it goes, it stands commended. Not so much may be said of its ability. This depends upon the work to which it is put. In certain lines it asserts preeminence, in certain others it is so far behind as to be out of the race. The reason for both is one and the same, for, as the French would say, it has the faults of its quality. The very trait that fits it for one function bars it from the other. This excellence is that by which the tortoise outstripped the hare, a plodding perseverance. Far less sensitive than the retina, the dry plate has one advantage over its rival: its action is cumulative. The eye sees all it can in the 20th of a second. After that, its perception, instead of increasing, is dulled, and no amount of application will result in adding more. With the dry plate it is the reverse. Time works for, not against it. Within limits, themselves long, light affects it throughout the period it stands exposed, and, roughly speaking, in direct ratio to the time elapsed. Thus, the camera is able to record stars no human eye has ever caught, and to register the structure of nebulae the eye tries to resolve in vain. Where illumination alone is concerned, the camera reigns supreme; not so when it comes to a question of definition. Then, by its speed and agility, the eye steps into its place, for the atmosphere is not the void it could be wished, through which the light waves shoot at will. Pulsing athwart it are air waves of condensation and rarefaction that now obstruct, now further, the passage of the ray. By the nimbleness of its action, the eye cunningly contrives to catch the good moments among the poor and carry the message to the brain. The dry plate by its slowness is impotent to follow. To register anything, it must take the bad with the better to a complete confusion of detail. For the airwaves throw the image first to one place and then to another, to a blotting of both. All of which renders the stars, where lighting counts for so much and form for so little, the peculiar province of celestial photography. With the study of the surfaces of the planets, the exact contrary is the case. With most of them, illumination is already to be had in abundance. Definition it is that is desired. What succeeds so excellently with the stars is here put to it to do anything at all. At its best, the camera is hopelessly behind the eye when it comes to the decipherment of planetary detail. To say that the eye is 10 times the more perceptive is not to overstep the mark. To try, therefore, here to supplant the eye by the camera is time thrown away. Of scant importance to the expert in such matters as Mars, there is a side of the subject in which service might be hoped of it, that of elementary exposition. Congenitally incapable of competing with the eye in discovery, the most that, by any possibility, could be looked for would be a recording of the coarser details after the fact. For this reason, it had long been a purpose at Flagstaff to photograph some at least of the canals. But the project seemed chimerical. To get an image suitable at all some seconds of exposure would be required, and during such time the shifting airwaves would blur the very detail desired to be got. It was a problem of essential premises, mutually annihilative. The more the would-be photographer should avoid the one, the more he would fall into the other. Nevertheless, the thing was tried in 1901. In 1903 the subject was taken up by Mr. Lampland, then new at the observatory. The results were better than those of 2 years before, the images more clear-cut, but still incommunicable of canals. Still, they were satisfactory enough to spur to increased endeavor, and during the following interopposition preparations were made to grapple with the planet as successfully as could be devised at its next turn. This happened in May 1905. It then showed a disk only 17 seconds in diameter, or 1/120th that of the moon, and this disk Mr. Lampland attacked with the 24-inch and a negative amplificator that increased the focal length of the former to 143 feet. At such focus, the planet's image was received upon the plate. Everything that could conduce to success had been put in requisition. To this end of better definition, the color curve of the objective was first got, and for it a special color screen constructed by Wallace. In spite of its name, no achromatic is so in fact, but brings rays of different tint to different focus. The color curve shows where these severally lie, and the color screen, a chemically tinted piece of glass, is to absorb all those which would blur the image by having a different focus from the ones retained. Next, all manner of plates were tried. For in these again it was necessary to reconcile 2 contradictory characters, a rapid plate and a well-defining one. For the coarser the grain, the speedier the plate, and coarse grain disfigures the detail. Both qualities on so small an image were obligatory, and yet both could not be got. Then the clock had to be as smooth running as possible. So, by a suggestion of Mr. Cockshall's, one was obtained that filled this requisite, a new form of conical pendulum. Upon this a further refinement was practiced. Ordinarily, clockwork is timed to follow the stars. This was altered to follow the planet, and so keep it more nearly motionless while its picture was being taken. Then the device of capping down the telescope to suit the air waves, which had been found so effective to the bringing out of fine detail, was put in practice. Lastly, all developers were tried, and those found suited to the finest work were used. Many pictures were taken on each plate one after the other, both to vary the exposure and to catch such good moments as might chance. 700 images were thus got in all, the days of best definition alone being utilized. The eagerness with which the first plate was scanned as it emerged from its last bath may be imagined, and the joy when on it some of the canals could certainly be seen. There were the old configurations of patches, the light areas and the dark, just as they looked through the telescope, and never till then otherwise seen of human eye, and there, more marvellous yet, were the grosser of those lines that had so piqued human curiosity, the canals of Mars. He who ran might now read, so that he had some acquaintance with photography. By Mr. Lampland's thought, assiduity, and skill, the seemingly impossible had been done. After the initial success was thus assured, plates were taken at other points around the planet, and other well-known features came out: continents and seas, canals and oases, the curious geography of the planet printed for the first time by itself in black and white. By chance, on one of the plates, a temporal event was found registered too, the first snowfall of the season, the beginning of the new polar cap, seen visually just before the plate happened to be put in and reproduced by it unmistakably. Upon the many images, 38 canals were counted in all, and one of them, the Nilocaris, double. Thus did the canals at last speak for their own reality themselves. End of section 24.
Section 25 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Mars and its Canals by Percival Lowell. Part 3. The Canals in Action. Chapter 23. Canals. Kinematic. So far in our account of the phenomena, we have regarded the lines, the spots, and everything that is theirs, solely from the point of view of their appearance at any one time. In other words, we have viewed them only from a static standpoint. In this we have followed the course of the facts, since in this way were the canals first observed. We now come to a different phase of the matter, the important disclosure, with continued looking, that these strange things show themselves to be subject to change. That is, they take on a kinematic character. This at once opens a fresh field of inquiry concerning them and widens the horizon of research. It increases the complexity of the problem, but at the same time makes it more determinate, for while it greatly augments the number of facts which must be collected toward an explanation of what the things are, these once acquired, it narrows the solution which can apply to them. The fact of change in the Martian markings forces itself upon anyone who will diligently study the planet. He will be inclined at first to attribute it to observational mistakes of his own or of his predecessors' making, preferably the latter, but eventually his own delineations will prove irreconcilable with one another, and he will then realize the injustice of his inference and will put the cause where indeed it rightly belongs, on the things themselves. Confronted by this fact, he will the more fully appreciate how long and systematic must be the study of him who would penetrate the planet's peculiarity. Just as the recognition of something akin to seasonal change came to Schiaparelli, because of his attending to the planet with an assiduity unknown to his predecessors, so it became evident that to learn the laws of these changes, and from them the meanings of the markings, there was necessary as full and as continuous a record of them as it was possible to obtain. For this end it was not enough to get observations from time to time, however good these might be, but to secure as nearly as might be a complete succession of such, day after day, month after month, and opposition after opposition. The outcome justified the deduction, and it is especially gratifying to realize that no one have the method and the results thus obtained appealed with more force than Schiaparelli himself. Perseverance in scanning the desk long after the casual observer had considered it too far away for observational purposes, resulted in Schiaparelli's detection of the canals, and this through a characteristic of theirs destined to play a great part in their history, their susceptibility to change. He tells us in his Memoria 1 how area and the adjoining regions showed blank of any markings while the planet was near in 1877 and the disk large and well shown, and then how, to his surprise, as the planet got farther away and the disk shrank, lines began to come out in the region with unmistakable certainty. Thus, to the very variability which had hidden them to others, was due in Schiaparelli's hands their initial recognition. Flux affecting the canals was apparent from the outset of my own observations, no less the subject of transformation than the large dark regions was the network of tenuous lines that overspread them. At times they were very hard to make out, and then again they were comparatively easy. Distance, instead of rendering them more difficult, frequently did the reverse. Nor was the matter one of veiling. Neither our own atmosphere nor that of Mars showed itself in any way responsible for their temporary disappearance. It was not always when our atmospheric conditions were best that the lines stood out most clearly, and as to Martian meteorology, there was no sign that it had anything whatever to do with their obliteration. Long before the canals were dreamt of, veiling by Martian clouds or mist had been considered the cause of these changes in the planet's general features, which are too extensive and deep-toned wholly to escape observation, even though none too clearly seen. It was early evident to me that they were not the cause of general topographic change, and equally clearly as inoperative as those that affected the canals. In short, nothing extrinsic to the canal caused its disappearance. Whatever that change was, its action lay intrinsic to the canal itself. On occasion, canals in whole regions appeared to be blotted out. The most careful scrutiny would fail to disclose them, where some time before they had been perfectly clear, and this though distance was at a minimum and definition at its best. Even the strongest marked of the strange pencil lines would show at times only as ghosts of their former selves, while for their more delicate companions it taxed one's faith to believe that they could ever really have existed. Illumination was involved to account for this, and plays a part in the effect undoubtedly, for at plumb opposition the center of the disk for 2 or 3 years had shown less detail than before and after the event. This is probably due not, as with the moon, to the withdrawal of shadows, but to the greater glare to which the disk is then subjected. But this is not the chief cause of the change. Still more striking and unaccountable was the fact that each canal had its own times and seasons for showing or remaining hid. Each had its entrances upon the scene and its exits from it. What dated the one left another unaffected. The Neelocaris was to be seen when the Chrysohoris was invisible, and the Gemuna perfectly evident when the Indus could scarcely be made out. So much shows in the 2 drawings here reproduced. The increase of the Ganges and the advent of the Chrysohoris are noticeably in the second over the first. Seasonal changes seem the only thing to account for the phenomenon, and in a general sense this was undoubtedly the explanation. To learn more about the matter, to verify if it existed, and to particularize it if possible, I determined to undertake an investigation permitting of quantitative precision in the case. A method of doing this occurred to me which would yield results deserving of consideration, from the amount of data upon which each was based, and capable of being compared with one another, upon an equal footing, from which relative information could be derived. It seemed wise to determine from the drawings the degree of visibility of a given canal at different seasons of the Martian year, and then to do this for every important canal during the same period of time. The great number of the drawings suggested this use to which they might be put. For from a great accumulation of data, a set of statistics on the subject could be secured in which accident or bias would be largely eliminated, and the telling effect of averages make itself felt. To render this possible, it was necessary that the drawings should be alike numerous, consecutive, and extended in time. These conditions were fulfilled by the drawings made by me at the opposition of 1903. 372 drawings had then been secured, and they covered between them a period of 6 months and a half. They were also as consecutive as it was possible to secure. During a part of the period, the planet was seen and drawn at every 24 hours, from April 5th, namely, to May 26th, or for 46 consecutive days. Though the rest of the time did not equal this perfection, no great gap occurred, and 143 nights were utilized in all. Furthermore, as these drawings were all made by one man, the personal equation of the observer, a very important source of deviation where drawings are to be compared, was eliminated. But even this does not give an idea of the mass of the data. For by the method employed, about 100 drawings were used in the case of each canal, and as 109 canals were examined, this gave 10,900 separate determinations, upon which the ultimate result depended. That each of these determinations was independent of the others will appear from a description of the method itself on which the investigation was conducted. To understand that method, one must begin a little way back. As the two planets, Mars and the Earth, turn on their axes, the parts of their surfaces they present to each other are constantly changing. For a feature on Mars to be visible from a given post on Earth, observer and observed must confront each other. And furthermore, it must be day there when it is night here. But as Mars takes about 40 minutes longer to turn than the Earth, such confronting occurs later and later each night, about 40 minutes, until finally it does not occur at all while Mars is suitably above the horizon. Then the feature passes from sight, to remain hidden till the difference of the rotations brings it round into view again. There are thus times when a given region is visible, times when it is not, and these succeed each other in from 5 to 6 weeks, and are called presentations. For about a fortnight at each presentation, a region is centrally enough placed to be well seen, for the rest of the period either ill-placed or on the other side of the planet. If a marking were always salient enough, it would appear in every drawing made of the disk during the recurrent fortnights of its display. If it were weaker than this, it might appear on some drawings and not on others, dependent upon its own strength and upon the definition at the moment, and we should have a certain percentage of visibility for it at that presentation, while if it changed in strength between one presentation and the next, the percentage of its recording would change likewise. Definition, of course, is always varying, but if its value be noted at the time of each drawing, this factor may be allowed for more or less successfully. Making such allowance, together with other corrections to produce extrinsic equality, such as the planet's distance, which we need not enter upon here, we are left with only the marking's intrinsic visibility to affect the percentages. That is, the percentages tell of the changes it has successively undergone, and give us a history of its wax and wane. From drawings accurately made, it is possible to add to the accuracy of the percentage by noting in each not only the presence or absence of the marking, but the degree of strength with which it is represented. This was done in the final investigation in the present case, and it was interesting to note how little difference it made in the result. The longitude of each canal was known, and the longitude of the central meridian of each drawing was also calculated and tabulated with the drawing, so that it was possible to tell which drawings might have shown the canal. Only when the position of the canal was within a certain number of degrees of the center of the drawing, 60 degrees, was the drawing used in the result, allowance being duly made for the loss upon the phase side. Each drawing, it should be remembered, was as nearly an instantaneous picture of the disk as possible. It covered only a few minutes of observation, and was made practically as if the observer had never seen the planet before. In other words, the man was sunk in the manner. Such mental effacement is as vital to good observation as mental assertion is afterward to pregnant reasoning. For a man should be a machine in collecting his data, a mind in coordinating them. To reverse this process, as is sometimes done, is not conducive to science. When the successive true percentages of visibility of a given canal had thus been found, they were plotted vertically at points along a horizontal line corresponding in distance from the origin to the number of days after or before the summer solstice of the Martian northern hemisphere. The horizontal distance thus measured the time, while the vertical height gave the relative visibility. The points so plotted were then joined by a smooth curve. This curve reproduced the continuous change in visibility undergone by the canal during the period under observation. It gave a graphic picture of the canal's change of state. It seemed, therefore, proper to call it the canal's cartouche, or sign manual. In this manner were obtained the cartouches of 109 canals. Now, as the presence or absence of any canal in any drawing was entirely irrespective of the presence or absence of another, each such datum spoke only for itself, and was an entirely independent observation. The whole investigation thus rested on 10,900 complete separate determinations, each as unconditioned by the others as if it existed alone. As every factor outside of the canal itself which could affect the latter's visibility was taken account of, and the correction due to it as nearly as possible applied before the cartouches were deduced, the latter represent the visibility of the canal due to intrinsic changes alone. In other words, they give not the apparent only, but the real history of the canal for the period concerned. Important disclosures result from inspection of the cartouches. This we shall perceive by considering what different curves mean in the case. If the canal were an unchangeable phenomenon, for any reason whatever, its cartouche would be a straight line, parallel to the horizon of the diagram. This is evident from the fact that the visibility would then never vary. If, on the other hand, it were waxing and waning, and the wax or wane were uniform, the cartouche would be a straight line, inclined to the horizontal, rising if the canal were increasing, falling when it decreased. Lastly, if the rate of change itself varied, the cartouche would be a curve, concave or convex, to the line denoting the time, according as the rate of change of the growth or decay grew greater or less. To see this more clearly, we may set over against the cartouche the canal character it signalizes. If the cartouche is a horizontal straight line, the character of the canal is invariable. If the cartouche is a straight line tilted up on the right, the character of the canal is increasing steadily. If the cartouche is a straight line tilted up on the left, the character of the canal is decreasing steadily. If the cartouche is a curved line descending concave from above, the character of the canal decreasing but more and more slowly. If the cartouche is a curved line ascending concave from above, the character of the canal is decreasing but more and more slowly. If the cartouche is a curved line descending convex from above, the character of the canal is decreasing more and more rapidly. If the cartouche is a curved line ascending convex from above, the character of the canal is increasing more and more slowly. If the cartouche is a curved line first descending, then ascending concave from above throughout, the character of the canal is decreasing more and more slowly to a minimum, thence increasing more and more rapidly. If the cartouche is a curved line first descending, then ascending convex from above throughout, then the character of the canal is increasing more and more slowly to a maximum, thence decreasing more and more rapidly. If the cartouche first falls and then rises, this shows the canal to have passed through a minimum state at the time denoted by the point of inflection. If it rises first and falls afterward, this betokens in the same way a maximum. Thus the cartouches reveal to us the complete history of the canals, what changes they underwent, and the times at which these occurred. The cartouche, then, is the graphic portrayal of the canal's behavior. It not only distinguishes at once between the dead and the living, as we may call the effect of intrinsic change, but it tells the exact character of this change, the way it varied from time to time, the epoch at which the development was at its minimum or its maximum for any given canal, and lastly, its actual strength at any time, thus giving its relative importance in the canal system. For the height of the curve above the diagrammatic horizon marks the absolute as well as the relative visibility, and enables us to rank the canals between themselves. Now, the first point it furnishes a criterion for is the real or illusory character of the canals. If a line be due to illusion, whether optical or physical, it can vary only from extrinsic cause, since it has no intrinsic existence. If therefore all extrinsic cause be allowed for, the cartouche of this ghost must needs be a horizontal straight line. If the extrinsic factors to its production be imperfectly accounted for, their attention could only cause systematic variations from the straight line in all the lines, which would themselves vary systematically, and these factors could therefore be detected. This criterion is absolute. Unless all the cartouches were approximately straight lines, no illusion theory of any kind whatever could explain the facts. Even then the lines might all be real, for unchangeable reality would produce the same effect on the cartouches as illusion. In the case, therefore, of horizontal straight-line cartouches, we should have no guarantee on that score of reality or illusion, but on the other hand, curves or inclined straight lines in them would be instantly fatal to all illusion theories. Turning now to the 109 cartouches obtained in 1903, the first point to strike one's notice is that all but 3 of them are curves, and that even these 3 must be accepted with a caveat. Here, then, the cartouches dispose once and for all of any and every illusion theory. They show conclusively that the canals are real objects which wax and wane from some intrinsic cause. The second result afforded by the cartouches is not of a destructive negative character, however valuable the destruction of bars to knowledge may be, but of a constructive positive one. It does not, like the first, follow from mere inspection, but is brought to light only by comparison of all the cartouches. In a positive way, therefore, its testimony is as conclusive as it was in a negative direction. For that 10,900 separate and independent data should result in a general law of development through either conscious or unconscious bias, when those data would have to be combined in so complicated a manner for the result to emerge as is here the case, is impossible. Chance could not do it, and consciousness would require a coordinate memory, to which Murphy's 9 games of chess at once would be child's play. Of the 109 canals examined, 106 showed by their cartouches that they had been during the whole or part of the period in a state of change. But the change was not the same for all. In some, the minimum came early, in others late. Some decreased to nothing and stayed there. Others increased from 0 and were increasing still at the time observations closed. Latitude proved the means of bringing comparative order out of the chaos. When the canals were ranged according to their latitude on the planet, a law in their development came to light, To understand it, the circumstances under which the canals were presented must be considered as regards the then season of the planet's year. In 1903, the planet passed on February 28th, through the point of its orbit where the summer solstice of the northern hemisphere occurs. 126 days later took place the first snowfall in the Arctic and subarctic regions, an event that denoted the beginning of the new polar cap, from which date the snow there gradually increased. Its autumnal equinox the planet did not reach till August 29th. Now the canals were observed from 36 days before the summer solstice of the northern hemisphere to 147 days after that event. We may tabulate the dates as follows. Minus 30 days from the summer solstice, the vernal longitude was 77 degrees. The corresponding date on Earth was June 9th. On the day of the summer solstice, the vernal longitude of 90 degrees corresponds to the date on Earth, June 22nd. 30 days from the summer solstice, the vernal longitude was 103 degrees. The corresponding date on Earth was July 6th. 60 days after the summer solstice, 117 degrees vernal longitude, corresponding date on Earth was July 20th. 90 days from the summer solstice, the vernal longitude was 131 degrees, and the corresponding date on Earth was August 4th. On August 20th, 120 days from the summer solstice, the vernal longitude was 146 degrees. And on September 5th, 150 days from the summer solstice, the vernal longitude was 162 degrees. The vernal longitude is the longitude of the planet in its orbit, reckoned from the vernal equinox. From the table, it appears that the cartouches cover the development of the canals from about June 6th to September 1 of the Martian northern hemisphere for the current, but to us undated year, ab Marta Candida. The 109 canals included all the more conspicuous canals on the planet at that opposition, all those that lent themselves by the sufficient frequency with which they were seen to a statistical result. They lay spread all the way between the edge of the polar cap in latitude 87 degrees north to the extreme limit south, at which the then tilt of the North Pole toward the Earth permitted of canal recognition. This southern limit was in about latitude 35 degrees south. Further south than this, vision became too oblique, amounting, as it did, with an adverse tilt of 25 degrees to start with, to something over 60 degrees for detection of such fine markings to be possible. Between the two limits thus imposed by the perpetual snow on the one side and the observational tilt on the other, the 109 canals were distributed by zones as follows. On the North Polar, 87 degrees north to 78 degrees north, 1 canal. In the Arctic zone, 78 degrees north to 66 degrees north, 9 canals. In the subarctic zone, 66 degrees north to 51 degrees north, 9 canals. In the north temperate zone, 51 degrees north to 37 degrees north, 11 canals. In the north subtropic zone, 37 degrees north to 24 degrees north, 18 canals. In the north tropic zone, 24 degrees north to 12 degrees north, 21 canals. In the north equatorial, 12 degrees north to 0 degrees north, 14 canals. South equatorial, 0 degrees north to 12 degrees south, 17 canals. South tropic zone, 12 degrees south to 24 degrees south, 7 canals. South subtropic zone, 24 degrees south to 37 degrees south, 2 canals. As the latitude of a canal in the investigation was taken as that of its midpoint, such being the mean value of its successive parts, the latitudes about which information was obtained lay within the limits given above. The most northern canal, the Jakartas North, having for its mid-latitude 78 degrees north, and the most southern, the nectar, that of 27 degrees south. The zones comprised each a belt of territory about 13 degrees wide, the first being less solely because in part occupied by the permanent solar cap. The curves of all the canals in a given zone have been combined into a mean curve or cartouche for that zone, and then the cartouches for the several zones have been represented and ranged according to latitude on the accompanying plate. Consideration of these mean canal cartouches is very instructive. In the first place, not one of them is a straight line, either horizontal or inclined. All are curves, and with the exception of the top one, all show a minimum or lowest point during the period under observation. From this point, they rise with the time, or to the right of the plate. A black star marks the minimum, and is found farther and farther to the right as one goes down the plate. That is, as one travels from the neighborhood of the Arctic regions down to the equator and then over into the planet's southern hemisphere. Drawing now a line approximately through the stars, and remembering that the minimum means the date at which the canal started to develop, we see that the canal development began at the border of the North Polar Cap, and thence continued down the disk over the planet's surface as far as observation permitted the surface to be seen, which was some 35 degrees into the other hemisphere. This is the first broad fact disclosed by the cartouches. Furthermore, the development took place at an approximately uniform rate. This is shown by the fact that the line passing through the black stars is approximately straight. For such straightness means that progression down the disk, as measured by the latitude, bore throughout the same ratio to the time elapsed. Looking at them again, we notice that the three topmost cartouches, those of the North Polar, Arctic, and subarctic canals respectively, dip at the right before the end of the observations, while the other 7 were still rising when those observations were brought to a close. A reason for this, or at least a significant coincidence, is to be found in the dotted line pendant from the top of the table and labeled First Frosts. This dotted line denotes the date at which the first extensive frost occurred in the polar regions, for even before this time, patches of white had appeared north of the Marcus Sigillium, denoting the oncoming of the cold. The frost did not last, but came and went and came again, just as it does on Earth, growing more insistent and long-lived at each fresh fall. Its sphere of operation was confined to the 3 zones in question. Even these zones it by no means covered, merely blotching them in places with fungi-like patches of frost. Beyond them south, it never extended during the period of the observations. Indeed, it hardly entered the subarctic zone at all at this very beginning of the polar winter, for it was only August 20 then. The coincidence of the isotherm as betrayed by the deposition of frost, with the dividing line between the canal development curves that dip down at this season and those that still continue to rise, is suggestive. It becomes all the more so when the 3 cartouches are considered seriatim. The most polewards, the North Polar one, had sunk to 0 some time before the first extensive frost occurred. The second, the Arctic, did so later than its northern neighbor, probably just before the epoch in question, while the third, practically outside the zone of deposition, was behind both the others in its descent. Inspection of the drawings upon which the cartouches are based confirms an inference deduced from this, that it was cold that killed, not frost that covered them, which was responsible for their obliteration. The drawings show that the canals ceased to be seen before the white patches were evident. Now, this would be the exact behavior of vegetation. It will be killed, turned brown by freezing, and so rendered invisible to us against its ochre desert background, before the cold had grown intense enough to cover that ground with a solid white carpet of frost. At the opposition of 1905, however, the extreme northern canals were visible after the snow had covered all the country about them, being evident as lines threading the new cap. These three cartouches, furthermore, show each a maximum, and what is significant, the maximum occurs later in time for each, according as the zone lies remote from the pole. A red star marks this maximum and shows that the time of greatest development for the three zones was respectively 41 days after the summer solstice for the North Polar, 61 days after the summer solstice for the Arctic, 95 days after the summer solstice for the subarctic. We now pass to the other curves, those that were unaffected by cold, though in these the minima themselves show the law of latitudinal progression. The wave-like character of the advance is even better disclosed by the curves. As the eye follows them down the page, the advance of the wave to the right is plainly apparent. The slope of the wave is much the same for all, implying that a like force was at work, successively down the latitudes. It will be noticed next that in all the mean cartouches, the gradient is greater after the minimum than before it. The curves fall gently to their lowest points and rise more steeply from them. Such profile indicates that the effects of a previous force were slowly dying down to the minimum, and that then an impulse started in to act afresh. This explains the attitude of the canals that died out. In them, the effect of the old force shows as in the others, but no impulse came in their cause to resuscitation. It seems possible to trace this force to an origin at the south, for beginning with the north subtropic zone, the gradient on the left shows less and less steep southward to the south subtropic zone. Such a dying down swell is what should be looked for in an impulse which had traveled from the south northward, since the wave would affect the more northern zones last, and less of a calm period would intervene between the two impulses from opposite poles. The cartouches, then, state that the canals began to develop after the greatest melting of the polar cap had occurred, that this development proceeded down the latitudes to the equator, and then, not stopping there, advance up the latitudes of the other hemisphere. In the next place, they show that in the Arctic region, the development was arrested, and devolution or decay set in as it began to get cold there, the most northern canals being affected first. Finally, that a similar wave of evolution had occurred from the opposite pole some time before and had then passed away. And this evidence of the cartouches is direct and independent of any theory. End of section 25.
Section 26 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit librivox.org. Chapter 24, Canal Development, Individually Instanced. As an interesting instance of the law of development, we may take the career of the Brontes during this same Martian year. The Brontes witnessing individually to the same evolutionary process that the canals collectively exhibit. The Brontes is one of the most imposing canals upon the planet. It is not so much its length which renders it a striking object, though this length is enough to entitle it to consideration, being no less than 2,440 miles. Its direction is what singles it out to notice, for it runs almost north and south. For this reason, it swings into a position to hold the center of the stage for a time with the precision of a meridian, as the planet's rotation turns its longitude into view. The points which it connects help also to add to its distinction, for the Sinus Titanium at its southern end and the Propontis at its northern are both among the conspicuous points of the disk. The latter is but 12 degrees farther east than the former, while it is 66 degrees farther north. This long distance, from nearly the line of the tropics in the southern hemisphere to mid-temperate regions of the northern, the canal runs in an absolutely straight course. Its north and south character commends it for any investigation of canal development, since it runs in the general direction that development takes. Its great latitudinal stretch further fits it for a recorder of changes sweeping down the disk, so that both in direction and length it stands well circumstanced for a measure of latitudinal variations. The fact that it is usually a fairly conspicuous canal does not detract from its virtue in this respect. It was first recognized at Flagstaff in 1894, but once realized, so to speak, it was possible to identify it with a canal seen by Schiaparelli, and supposed by him to be the Titan. Indeed, it played hide and seek with that canal throughout his drawings. In 1894, both it and the Titan were so well seen that its separate existence was unmistakable, causing it to be both recognized and named. It is, like the Titan, one of the sheaf of canals descending the disk from the sinus titanium, and lies just to the east of the Titan in the bunch. In 1896, it was also prominent, and at both these oppositions, most so from its southern end, its northern one being more or less indefinite, especially in 1894. In 1901, it was not the same. Instead of being the conspicuous canal it had been in earlier years, it was now so faint as with difficulty to be made out. It remained so to the close of observations. It was now under suspicion. Its behavior in 1896 to 1897 had led to the supposition that not only were seasonal changes taking place in it, but that those changes were such as to point to a law in the case with which its conduct in 1901 faded in. The suspicion did not, however, become a certainty till the opposition of 1903. The length of time during which the disk was then kept under scrutiny resulted in the method of its metamorphosis being discovered. At the very start of observations, its longitude chanced to be nearly central and it was made out, but so far off was the planet that only its northern part could be detected, because, as afterward appeared, this part was the stronger, the canal being decidedly inconspicuous, whereas other canals, the northern and even the Pallene and the disk, were strongly marked. At the next presentation the planet was nearer, and details previously hidden for the distance now came out. Among them was the Brontes, which, showing better than in January, could be traced all the way to the sinus titanium. A drawing made on February 25 and reproduced in the test shows its appearance at the time. Its emergence under near conditions only served to accentuate its relative inconspicuousness, for it showed now notably inferior to the northern canals, and this not only in the matter of general visibility, but in the character it displayed. It was a line of hazy definition, contrasting thus with the sharp dark forms of its northern neighbors. As the planet steadily approached the Earth, and the canals to the north became better and better seen, the Brontes, instead of sharing in the general improvement, did exactly the opposite. It grew less visible when it should have grown more so. If distance had been the cause of its appearance, it was now only to be seen at the north, even when it was seen at all, a state of things exemplified in drawings 2 and 3. As the planet now went away and details should have dimmed, the Brontes proceeded to do the opposite. One had almost said it was actuated by a spirit of contrariety, for now, when it had reason to grow faint, it grew in conspicuousness, just as before, when it should have become evident, it had declined. Distinctly, farther off and smaller as the planet was at the next presentation, the Brontes had clearly developed both in tone and in the amount of it visible. This was in May, drawings 4 and 5. In June bad seeing prevented good observations, but in July, drawing 6, when the region again came round, the Brontes, in spite of the then greatly increased distance, asserted itself so strongly that even in not very good seeing its presence could not be passed by. This contrariety of behavior had about it one very telling feature. That the canal west or waned in exact opposition to distance and even toward the last to seeing too, showed conclusively that neither distance nor definition could in any way be held responsible for its metamorphoses. A very fortunate circumstance, this of the observations, for it directly eliminated size of disk, phase, and seeing, for which correction are none too easy to make, and which in the minds of the sceptical could always remain as unexplained possibilities of error. The mean canal cartouches show synthetically, and all the more conclusively for being composite, the laws of the floods of the canals. Something more of vividness, however, is imparted by the actual look of one of the constituents during the process. It is the difference between seeing a composite picture made from a given group of men and the gazing on the actual features of any one of them. So much is gained by the drawings across the page of the Montes at different stages of its evolution during the period here concerned. But in another way too, the one canal may be made to yield a more lifelike representation of the process than a number taken together are capable of affording. In the mean canal cartouches, each canal is treated as an entity, but it is possible to consider a canal by parts, and by so doing to see it in action as it were. It occurred to me to treat the Montes in this way. For this purpose I divided the canal into sections, 5 of them in all, between the point where it left the Propontis, at a spot called the Propontis, to where it ended in the sinus titanium. The first, the most northern, extended as far as Samnon Lucas, the southernmost outpost of the Propontis congeries of spots. The second continued on from these to Elian, the junction where the Erebus crossed. The third thence to Utopia, where the canal met the Orcus. The fourth to an arbitrary point in latitude 8 degrees south, and the fifth and last to the sinus titanium. The lengths of these sections were respectively 12 degrees, 16 degrees, 15 degrees, 12 degrees, and 13 degrees. Each of the sections was then treated as if it were a separate canal and its cartouche found. To the cartouche's determination there were available drawings. January 21 to 25, 12 drawings. February 23 to March 2, 15 drawings. March 28 to April 5, 14 drawings. April 26 to May 8, 27 drawings. June 3 to 16, 6 drawings. July 11 to 21, 16 drawings, 90 drawings in all. The cartouches are given in the plate opposite, which is constructed precisely like the one for the mean canal cartouches presented on page 298. The mid-latitude of the section and its mid-longitude are given in the margin with its description. Examining them now, we note a family resemblance between the successive cartouches. All sink slowly on the left to rise sharply from their lowest point to the right. Such resemblance betokens the action of one and the same cause. Next, although the curves are resemblant, each has been, as it were, sheared to the right as one reads down. That is, the action took place later and later as the latitude was north. Lastly, the dying out of a previous impulse can be traced in the cartouches, which shows that the canals were quickened 6 months previously from the South Polar Cap, as they were now being quickened from the North Polar one. End of section 26.
Section 27 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Melanie Young. Mars and its Canals by Percival Lowell. Chapter 25. Hibernation of the Canals. Connected with the conduct of the canals is a phenomenon, examples of which were early noted in a general way by Schiaparelli and later, but of which the full import and exhibition only came to light during the opposition of 1903 by a very striking metamorphosis. What may be called the hibernation of a canal for a longer or shorter term of years. What observation discloses is certainly curious. For several successive oppositions, a canal will be seen in a definite locality, as regular in seasonal recurrence as it is permanent in place, a well-recognized feature of the disk. Then, to one's surprise, with the next return of the planet, it will fail to appear, and will proceed to remain obliterate without assignable cause for many Martian years, until as unexpectedly it will be found what and where it was before. Neither to deposition of hoarfrost, such as frequently whitens whole regions of Mars, nor to other circumstances can be attributed its disappearance. Without apparent reason, it simply ceases to be, and then as simply comes back again. Such bo-peep behavior is quite beyond and apart from the seasonal change in visibility, to which all the canals are by their nature subject. For being creatures of the semi-annual unlocking of the water congealed about the polar caps, they quicken into growth and visibility, each in its season, and as regularly die out again. Different, however, is the phenomenon to which I now refer. In it, not a seasonal but a secular change is concerned. The season proper to the canal's increase will recur in due course, and the canals round about it will start to life, yet the canal remains unquickened. Nothing responds where in years the response was immediate and invariable. The canal lies dormant, spite of seasonal solicitation to stir. Such curious hibernation was early hinted to the keenness of Schiaparelli, and most incomprehensible as well as difficult of verification at that stage the phenomenon was. That the absence was a fact, however, he assured himself, although he was not able to prove an alibi. But at the last opposition, an event of the sort occurred which, from the length of time the planet was kept under observation, combined with continued suitableness of the seeing, unmasked the process. In the light of what then happened, taken in connection with the sidelights thrown upon it by the canal's past and by the knowledge we have meanwhile gained of the planet's physical condition, the riddle of the phenomenon may in part at least be read, and most interesting and instructive the reading proves to be. Among the initial canals detected by Schiaparelli in 1877 was a tricrural set of lines recalling the heraldic design of 3 flexed legs, joined equiangularly above the knees. It lay to the east of the Syrtis Major, and he called its 3 members the Thoth, the Triton, and the Nepenthes. Starting from the head of his Gulf of Alcyonius, at a point now known to be occupied by the oasis called Aquae Calidae, the Thoth started south, inclining westward as it went, till in longitude 267 degrees and latitude 15 degrees north, it met the Triton, which had come from the Syrtis Minor with similar westward inclination. To the same point in the same manner came the Nepenthes. Part way along the course of the latter was to be seen a small dark spot, the Lucus Moeris, which he estimated at 4 degrees in diameter. Some of the markings were easier than others, the easiest of all being the Lucus Tritonis, a largest dark spot at the common intersection of all 3 canals. But that none of the markings were remarkably difficult is sufficiently shown by their detection at this early stage of Schiaparelli's observations. It is worth noting also that he discovered the southern ones first, the Thoth not being seen till March 1878. As his then recognition of these canals witnesses, they must have been among the most evident on the disk. And the point is emphasized by the fact that he failed at this opposition to detect the Phison and the Euphrates as separate markings. Much the same the 3 canals appeared to him at the next opposition of 1879, the Thoth being seen at its several presentations, from October 5, 1879 to January 11, 1880. At the next opposition, a noteworthy alteration occurred, the full significance of which escaped recognition. Schiaparelli saw, at the place where the Thoth had been, 2 lines which he took for a gemination of that canal, one of which followed the course of the old Thoth, while the other went straight from the Sinus Alcyonius to the Little Syrtis, or, more precisely, to the junction of the Triton and the Lethes. It was not the Thoth, however, but something unsuspected, of more importance. In 1884, the Thoth showed really double, the western line being much the stronger. That neither branch went farther than the meeting place with the Nepenthes argues that it was indeed the Thoth that was seen. Schiaparelli himself had no doubt on the subject, although he drew the double canal he saw due north and south from the tip of the Sinus Alcyonius to the junction, but nevertheless along the 263-degree meridian. In 1886 and 1888, the system was in all essentials what it had been in 1877 and 1879, except that the Thoth and Nepenthes were double and were more minutely seen. Here, then, was a system of canals and spots which for 6 Martian years had been a persistent and substantially invariable feature of the Martian surface. Any changes in it had been of a secondary order of importance, while its general visibility was of the first. It is possible, then, to judge of my perplexity when, in the beginning of my observations in 1894, no sign of this system could I detect. Of neither the Thoth, the Triton, the Nepenthes, nor the Lucus Moeris was there trace. And yet from the other canals visible, it was evident that the disk was quite as well seen as it had been by Schiaparelli. Not only were practically all his canals there, but many much smaller ones were to be made out. And the same was true of the spots, a host of such not figured by him, appearing here and there over the planet's surface. Nor was this all. Instead of the Thoth, another canal showed straight down the disk, from the Syrtis Minor to the Aquae Calidae. This canal was as unmistakable as the Thoth had been before to Schiaparelli. It was among the first to be detected, and continued no less conspicuous to the end. The dates at which it was seen being July the 10th, August 14th, and October 21st. I called it the Amenthys, identifying it with the canal so named in Schiaparelli's chart published in Himmel und Erde. Of the ensemble of his observations from 1877 to 1888. But in his memoirs he never called it so, seeing it indeed only in 1881 through 1882, and deeming it then the Thoth. Nevertheless, in 1894, it was the conspicuous canal of the region, and what is more, had come, as it proved, to stay. The invisibility of the Thoth continued for me the same during the succeeding oppositions of 1896 through 1897 and 1901. At the former opposition, I drew it in 1896 on July the 28th, August 26th, September 2nd, October 5th through 9th, seeing it single, and in 1897 on January 12th through 19th, February 21st, and March the 1st. It was single but with suspicions of doubling in January, and was indubitably double in February. As for the Thoth, I had come to consider it and the Amenthys as one, attributing their diversity of depiction to errors in drawing, for while the Thoth remained obstinately invisible, the Amenthys presented itself as substitute so insistently as to make one of the most obvious canals upon the disk. One exception only was there to this state of things. On June the 16th, 1901, my notes contain this adumbration of a something else. Amenthys sometimes appeared with a turn to it 2/3 way up, 2 canals concave to the Syrtis Major. So matters opened at the opposition of 1903. With the advent of the planet and the presentation in due course of Libya in February, the Amenthys duly appeared, much as it had showed at the opposition before, only less salient. It was a confused and seemingly narrower double. Suspected on the 16th of that month, it was definitely seen from the 18th to the 23rd. Of the Thoth no mention is made either in the notes or in the drawings. When the region came round again in March, the Amenthys was still there, showing more feebly, however, than it had in February, in spite of better seeing and the fact that the planet had considerably neared. Clearly the canal was fading out, a fact further witnessed to by the following note made on March 25th. Throughout this opposition, thus far, the dark triangle tipped by Aquae Calidae has been sharply divided in intensity from the Amenthys, which is very narrow and exceedingly faint. Still, there was no trace of the Thoth. With the April presentation entered a new order of things. When the region first became visible on the 16th, the Amenthys could still be seen and alone. But on the 19th, as the relative falling back of the Martian longitudes swung the region nearer the center of the disk, the Thoth appeared alongside of it. On the 20th, the Thoth showed alone. Unmistakable it was, and just as Schiaparelli had drawn it, accompanied by the Triton and the curved Nepenthes. The thing was a revelation. What before I had seen only in the spirit of another's drawings stood there patent to me in the body of my own, while the Amenthys, to which I had so long been accustomed, had vanished into thin air. Only a trace of it was now and then to be made out. So startlingly strange was the metamorphosis that I could not at first trust my eyes, and questioned the broken line which had replaced the straight for some ocular deception. But nothing I could do would rectify it. The Amenthys was gone, and the Thoth stood in its stead. At the next presentation, May 26th to June 8th, the phenomena were repeated, and with increasing clarity. And then, of a sudden, on May 29th, I saw the long-given-up Lucus Moeris. There it was indubitably, and its definiteness was the most astonishing part of the affair. It was no question of difficult detection. Indeed, I had not been on the lookout for it, having searched the region too often fruitlessly before to have left incentive to search again. And so when I was not searching, the thing of its own accord stepped forth to sight. It was a small round dot, like to any other oasis, and showed, as it were, a black pearl pendant by the Nepenthes from the Syrtis's ear. For the Libyan bay made a dark projection of the sort high up on the Syrtis's eastern side, from which the Nepenthes, precisely as Schiaparelli had drawn it, curved down to the point where the Thoth and Triton met. All three canals were geminated, the gemination being about 3 degrees wide. And now occurred the last act in the drama. In July, the Amenthys reappeared, showing alongside of the Thoth Nepenthes, and thus removing any possible doubt as to their separate identity. It had indeed become the stronger of the two, having gained in strength in the interval between June and July, and the Thoth Nepenthes having lost. The lines were in process of relapsing into the status quo ante. Had these three presentations not been watched, the brief apparition of the Thoth Nepenthes had been missed, and with it the revealing of its curious character, and of certain deductions thereupon. First among these is a truth of which I have long been convinced, to wit, that when a seeming discordance arises between the portrayals of a canal, it is commonly not a case of mistake nor of change, but one of separate identity. The canal has not shifted its place, nor has an error been committed. The fact is that one canal has been observed at one time, another at another. So it was here, and thus were the old and the new observations reconciled. There had been no mistake in either. 2 separate canals accounted for the discrepancy, and only an unfounded distrust of the accuracy possible in such observations was to blame for any failure to recognize the fact. Now, scrutiny of the notes upon the appearance of the two canals, together with their labeling by the seasonal longitudes of the planet at the dates they were made, discloses a curious relation between the two. The seasonal longitudes are important, as they date the phenomena according to the Martian calendar. Ordered thus, the successive aspects reveal first a seasonal change in each canal, and then over and above this a secular one. And this secular change was such as to cause the two canals to alternate in visibility. When the one was present, the other was not, and vice versa. We shall see this more clearly and at the same time bring out a curious relation between the two systems. The broken bow of the Thoth Nepenthes Triton and the straight arrow of the Amentes, while looking at the cartilages of the Thoth, the Amentes, and a combination of both given in the plate on the previous page. The antithetical character of the two canals is apparent, but what is further interesting, the combination cartouche of both bears a singular resemblance to that of the mean canal of the North Tropic Zone, the zone to which both canals belong. Here, then, is a combination which is perfectly regular while each of its constituents is anomalous. And now we come to something as important. At the opposition of 1905, the curious alternation, metamorphosis, was enacted anew. The Amentes appeared, disappeared to be replaced by the Thoth, and then reappeared again beside the other. This corroboration of behavior showed the previous observations to have been due to no mistake, and only served to deepen the interest in this last and more singular phase of canal conduct. End of Section 27. Recording by Melanie Young.
Section 28 of Mars and its Canals. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Giordano. Mars and its Canals by Percival Lowell. Chapter 26. Arctic Canals and Polar Rifts. Last in time, but not least in importance of the details of canal development to be detected is one that connects these strange features directly with the melting of the polar caps. The cartouches showed that such connection was to be inferred. The facts now to be recorded depict it by an identity of place between certain phenomena of the two subjects following one another in order of time. On January 8, 1897, while scanning the planet, I was suddenly aware of a rift in the north polar cap. It ran a little to the west of south from where it started in at the cap's edge, and went clean through to the limb, the pole being then slightly tilted away from us. At the time it seemed to be the first rift ever seen in that cap, but on opening a little later Schiaparelli's Memoria Corta, which had just arrived, the first thing my eye fell on was a drawing of the rift in the north polar cap observed by him when the planet had held the like attitude toward the earth 13 years before. Reference to its longitude showed it to be the identical rift, seen again after all these years, and the only one so far seen in the northern cap. At the next opposition more rifts were detected, one in especial on December 27, running from Arethusa Lucas, then upon the edge of the cap, athwart the snow, in a northwesterly direction. In the forepart of the opposition of 1901, which in its Martian season corresponded to that in 1897, when the rift had been observed, many rifts were detected in the cap, and among them one traversing the cap northeasterly in longitude 136 degrees. So far the season when the cap had been observed was that when the rifts were in process of forming. The ground they and the snow cap covered had not yet at any opposition been uncovered. It was only when my observations began in the latter half of the opposition of 1901 that, the season of Mars having so far advanced, all snow in those latitudes had melted. Then appeared, however, the canal Hippalis, an Arctic canal of some importance, lying on that part of the planet previously occupied by the polar cap. When later studying the observations on the rifts, I remembered this canal, and turning to the drawing made some months before to compare the two critically, discovered that the canal occupied the precise position held earlier by the rift. One had said the rift had never vanished, but that the white surrounding it had simply turned to ochre. Here, then, was a striking coincidence of place, too exact to be the result of chance. Impressed by the identity, I examined all the other rifts seen early in 1901, comparing them with the Arctic canals seen later, to the finding of no less than 5 cases of the same coinciding positions. The importance of the identification here made of an Arctic canal with a previous rift in the polar cap has led me to make a list of the canals thus identified at this opposition. Now follows a chart. Hibernation, visible as a rift, January 1 and February 4th, visible as a canal, April 18, ? May 20, May 22nd, May 27, June 4, June 5, June 6, June 7, June 8th, June 25th. Hippalis, visible as a rift, January 19th and February 4. Visible as a canal, April 18, May 27. Rhombides, visible as a rift, February 4. Visible as a canal, May 27. Python, visible as a rift, February 20. Visible as a canal, March 31. Zygatus, visible as a rift, January 18, January 19. Visible as a canal, May 7, June 3rd to 8. End of chart. If it be asked why these canals did not appear recorded at the March presentation as either the one phenomenon or the other, the answer is twofold. First, because they showed as shadings lost amidst a shaded mass, and secondly, the observations at several oppositions indicate a great amount of haze over the region at that season of the Martian year. We may now go back to the first rift, that of 1897. The Martian season grew later with each succeeding opposition, and it so chanced, abetted by this fact, that the delaying snow was never seen covering that part of the planet again, and so, of course, not the rift. The Martian summer in those high latitudes came on, and with it brought the great Arctic canal, the Jaxartes, into conspicuousness. The canal, in consequence, had been observed for some time before it proclaimed itself the apotheosis of a rift, and that of the first and most important rift of all. Comparison of position, however, entirely confirmed the conjecture, and added another and the most striking of all to the list. These 6 canals, on the whole the largest which run into the northern cap, have thus a dual character. Starting originally as rifts, they later come out unmistakably as canals, so that we may say in general that the two phenomena are different seasonal states of the same thing. This instantly explains the rifts, the origin of which we found of so difficult, not to say impossible, interpretation before in these pages, and incidentally it confirms what we deduced on other grounds as the character of the canals, to wit, strips of vegetation. For if the cap cover desert and fertility alike, it is precisely over the latter that it would first melt. Vegetation has the property of melting snow. The metabolism of the plant, like that of the animal, though in a less degree, generates caloric. A living animal is warm, even the so-called cold-blooded ones, in some sort, and a growing plant is too. The chemic processes concerned give off heat, though in such small quantities that we are often not aware of it. While the plant lies dormant, it stays cold, but the moment its sap begins to run under the rays of the spring sun, it rises in temperature above its winter surroundings. All it needs to this awakening is sun and water, and both it gets in its place in the polar cap, after the passing of the vernal equinox. The time, therefore, is suitable, for it is not till after that equinox is past that any of the above phenomena occur. In consequence, the snow about it melts, and the plants themselves show as dark rifts splitting the cap. This quite unexpected identity of two seemingly diverse phenomena, and the unsolicited support its only explanation lends to the general theory, is an instance of what is constantly occurring as observation of the planet is pushed farther and farther. Facts every little while arise which prove to fit into place in the scheme when neither the facts nor their fitness could have been foreseen. End of section 28. Recording by Greg Giordano, Newport Richey, Florida.
Section 29 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by EdwardMontes, Las Cruces, New Mexico. Mars and its Canals by Percival Lowell. Chapter 27. Oases, Kinematic. Subject to change also are the oases, and in the same manner apparently as the canals. They grow less evident at a like season of the Martian year. They do this seemingly by decreasing in size, whereas in the full expanse of their maturity they show as round spots of appreciable diameter. As the season wanes, they contract to the smallest discernible of dots. All but the kernel, as it were, fades out, and even this may disappear from sight. The Phoenix Lake in its summertime is a very dark, circular spot, small indeed, yet of definite extension. In its winter, it shrinks to a pinpoint, and is often not visible at all. Sometimes the husk apparently persists, a ghost-like reminiscence of what it was, with the kernel showing dark-pointed in its center. Thus the Lucus Lunae, appearing in opposition in 1905. A faint wash betokened the presence of the Lucus, through which now and again a black pinpoint pierced. In this visible decrease of size, we get a revelation as to what takes place, impossible in the case of canals, the tenuous character of which precludes more than inference as to the process. Like the canals, latitude, together with the suitable season of the planet's year, are the determining factors in their development. In what corresponded to our July of the Northern Hemisphere, the oases in the subarctic and north temperate zones are conspicuous. Black spots that showed in profusion along the parallels of 40 degrees, 50 degrees, and 60 degrees north. At the same time, the equatorial ones, those along the Eumenides Orcas, which had been most evident in 1894, hardly came out. It had been their time as it was that of the others now. The law of development is not so simple as on Earth, depending, like that of the canals, not only upon the return of the sun, but upon the advent of the water let loose from about the polar caps. Thus, the equatorial oases are subject to two seasonal quickenings, one from the north, the other from the south. In regard to their method of evolution or devolution, a most curious observation happened to me in 1903. Usually the oases are of solid tone throughout, equally somber from center to circumference. But in this case, such uniform complexion found exception. On March 1st, 1903, the Ascraeus lucus came out strangely differentiated, a dark rim enclosing a less dark kernel. The sight was odd enough to command comment in the shape of a sketch which accompanied the note, and the further remark that other spots had similarly that year affected the like look. That the effect was optical did not seem to me the case. Other spots at other times showed nothing of the sort. If it was due to objective cause, it gathers circumstance from what was then the Martian time of year. For the season was such that the spot should then have been in the process of waning, and the effect would indicate that in so doing the tone of the center went first, that of the circumference fading last. This would be in accordance with a growth proceeding outward and a decay that followed in its steps. When to this we add the look of the oasis at the antithetic season, often a faint shading only, with or without a darker pinpoint at its core, we are led to the belief that the area of the oasis is unchangeable and that its growth means a deepening of tint. So far, then, as it is possible to particularize them, the oases develop from a small nucleus, perhaps 20 miles in diameter, perhaps less, and from this spread radially till they attain a width of 75 or 100 miles. If the oasis be associated with a double canal, this maximum width exactly fits the space between the twin lines. Even when no double enters the oasis, the size is about the same. This size attained, they hold it for some months. Then they proceed to fade out to their initial nucleus, and after a sufficient rest, the process starts over again. With the carets, something of the same sort seems to take place. If we may consider as betokening a general law the fact that in 1894 the carets at the mouths of the Physon and Euphrates developed before their affiliated canals. But about them much less is yet known, and we must be content to say that the observations of 1905, made at the opposite season of the canal's year, seem to bear this out. End of section 29, recording by EdwardMontes, Las Cruces, New Mexico.
Section 30 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michael Knowles, Fort Worth, Texas. Mars and its Canals by Percival Lowell. Part 4, Explanation. Chapter 28, Constitution of the Canals and Oases. As rational science does not rest content with raw results, it now becomes obligatory, by marshalling the facts to suitable discussion, to seek to find out what they mean. Now, so soon as we scan these phenomena for some self-interpretation, we perceive one characteristic of the lines which at once appears to direct us to their nature and justifies itself as a signpost with increasing certainty as we read on. This trait is the very simple yet most significant one of showing intrinsic change. The lines alter in visibility with time. This primary proclivity we do not even need the cartouches to establish. That the lines change is palpable to anyone who will watch them long enough. Schiaparelli was struck by the fact early in his study of the planet, and it forces itself on the notice of any careful observer who compares his own observations with one another at intervals. But, though the cartouches are not needed to a first revelation of mutability, they serve to certify and precise it to much further information on the subject. For that these changes are not extrinsic, that is, are not caused by varying definition, distance, or illumination, they make patent even to those who have never seen the things themselves by disclosing respective differences of behavior in lines similarly circumstanced optically. The change is therefore intrinsic, and the question arises to what such intrinsic change can be due. In searching for cause, attention is at once attracted by another series of transmutations that manifests itself upon the disk in the orderly melting of the polar caps. For the existence of the two set of metamorphoses suggests the possibility of a connection between them. The inference is strengthened when we note that not only are both periodic, but that furthermore, the period of the two is the same. Each polar cap runs through its gamut of change in a Martian year. The canals also complete their cycle of growth and decay in a Martian 12-month. The only difference between the two is that each polar cap has but one maximum and one minimum in the course of this time, while most of the canals have two of each, though the maxima are not alike, nor the minima either. Not only is the period of the two series of changes the same, but the one follows the other. For the development of the canals does not begin till the melting of the polar cap is well underway. Now, as the polar cap disintegrates, it gives rise, as we have seen, to a dark belt of blue-green, which fringes its outer edge and retreats with it as it shrinks. This tells, directly or indirectly, of a product let loose. After this belt has been formed, the canals nearest to it proceed to darken, then those a little farther off follow suit, and so the wave of visibility rolls in regular routine down the disk. Here then, at the outset, we have a chronic connection between the two phenomena, the disintegration of the cap and the integration of the canals. Of water, we saw that the caps were undoubtedly composed, and to water, then, let loose by the melting of the cap, we may inferably ascribe the thaumaturgy in the development of the canals. But it is not necessary to suppose that this is done directly. That the increased visibility of the canals can be due to a bodily transference of water seems doubtful, if for no other reason than the delay in the action. Considerable time intervenes between the disappearance of the cap and the appearance of the canals, except in the case of such as have been covered by it. Transformation consequent on the transference, however, would account for the hesitancy. A quickening to vegetal growth would produce the counterpart of what we see. If set free from the winter locking up, the water accumulated in the cap, then percolated equatorward, starting vegetation in its course, this would cause the increased visibility of the canals and, at the same time, explain the seeming delay by allowing for the time necessary for this vegetation to sprout. This is certainly the most satisfactory explanation of the phenomena. Thus started, the vegetal quickening would pass down the planet's surface and give rise to what we mark as seasonal change. But, though in one sense of seasonal character, a little consideration will show that it would be quite unlike the seasonal change which we know on Earth. Could we see our Earth from some standpoint in space, we should mark with the advent of spring a wave of verdure sweep over its face. If freedom from cloud permitted of an unimpeded view, this flush of waking from winter's sleep would be quite evident and could be seen to spread. Starting from the equator, so soon as the sun turned north, it too would travel northward and, distancing the sun, arrive by midsummer well into the Arctic zone. Here, then, we should note, much as we note it on Mars, a tint of blue-green superpose itself successively on the ochre ground, but mundane and the Martian vegetal awakening would differ in one fundamental respect. The earthly wave would be seen to travel from equator to pole, while the Aryan travels from pole to the equator. Though clearly seasonal in character, both of them, the transformations would be opposite in action. Some other cause, then, must be at work for what we are familiar with on Earth. This other cause is the presence or absence of moisture. Two factors are necessary to the begetting of vegetal life, the raw material and the reacting agent. Oxygen, nitrogen, water, and a few salts make up the first desideratum. The sun supplies the second. Unless both be present, the quickening to life never comes. Now, the one may be there and the other not, or the other there and the one not. On Earth, the material, including water, is, except in certain destitute localities, always present. The sun is it that periodically withdraws. Observant on the return of the sun is, therefore, the annual recurrence of vegetal growth. On Mars, on the contrary, water is lacking. This we now know conclusively from other phenomena the disk presents, which have no connection with the present investigation and are, therefore, unprejudiced witness to the fact. No permanent bodies of water stud its surface. That the so-called seas are traversed by dark lines permanent in place is one of several proofs of this. The only surface water the planet knows comes from the melting of its polar caps. Vegetation cannot start until this water reaches it. Consequently, though the sun be ready, vegetation must wait upon the coming of the water, and, starting from near the pole, follow the frugal flood equatorward. Now, such contrariety of progression of what we should observe in the case of the Earth, could we view it from afar, is exactly what the curves of visibility of the canals exhibit. Timed primarily not to the return of the sun, but to the advent of the water, vegetal quickening there follows, not the former up the latitudes, but the latter down the disk. For better understanding, the two curves of phenological quickening, the mundane and the Martian, are shown in the diagrams. The plates represent the surfaces of the two planets, that of the Earth being shown upside down with south at the top as to agree with the telescopic depiction of the topography of Mars. The stars mark the epoch of the dead point of vegetation at successive latitudes, the time increasing towards the right. The curves, it will be noticed, are bowed in opposite ways. The bowed effect is due, in part, to Mercator's projection. In part, it may represent a real decrease in speed with time. But what is strikingly noticeable is the opposite character of advance to the right, the one curve running up the disk, the other down it. This shows that the development of vegetation proceeded in opposite directions over the surface. Thus is the opposed action of the two planets accounted for, and we are led to the conclusion that the canals are strips of vegetation fed by water from the polar caps, and that the floral seasons there as affecting the canals are conditioned not as they would be with us, directly upon the return of the sun, but indirectly, so through the direct effect upon the polar snows. Once adventured on the idea of vegetation, we find that it explains much more than the time taken by the wave of canal development down the disk. It accounts at once for the behavior of the canals in the three northern zones, the polar, Arctic, and subarctic. The mean cartouches of these three zones dip down at their latter end instead of rising there, as in the case with the cartouches of the mean canals farther south. This dip denotes that the most northern canals were waning already by the middle of their August, though the others showed no such tendency. While the date of the deposition of the frost in these northern latitudes shows that they were started upon their course towards extinction before the snow itself had covered them. In other words, they were not obliterated, but snuffed out. That their decline was thus preparatory to the coming of the first snowfall or frostfall, sufficiently severe to whiten the ground, so that it did not melt the next day, is suggestive of their constitution. It is clear that they were not abruptly cut off by the frost, but were timed by nature to such extinction. Vegetation would behave in just this way, since evolution would accommodate the career of the plant to its environment. The first question to present itself chronologically in the canal's annual history is connected with the size of the cap. Unfortunately for the simplicity of the phenomenon, this cap is not an extensionless source of flow, but an extended surface melting from the outer edge in. It would seem, therefore, that water liberated from the outer parts should have an effect before the main body of it were ready to begin its general march down the disk. There should be, one would think, at least a partial action locally before the main action got underway. Now, there are certain canals that show cartouches increasing apparently from the time the observations began, and the most pronounced is the Jaxartes, which lies of all the canals observed the farthest north. Now, the cartouches were founded on canals quickened from the North Polar Cap. The farther north the canal, therefore, the greater the likelihood of its showing the phenomena. That we note such canals is therefore not only not subversive, but actually corroboratory of the law it seems at first to shake. That all the canals of these zones do not show alike cartouche profiles is not necessarily a part of them being dependent, not upon the earlier, but upon the latter liberated flow, and thus partaking in the general law which grows uniform lower down the latitudes. As the action from one polar cap proceeds, not only down to the equator, but across it into the planet's other hemisphere, it appears that much, at least, of the surface of Mars has two seasons of vegetal growth, the one quickened of the North Polar Cap, the other of the southern. How far the polar spheres of action overlap, it is not possible at present to affirm, as the canals at this opposition were only visible to 35 degrees south latitude. That the North Polar quickening goes down so far is vouched for, and it is probable from other observed phenomena that it goes farther. The alternate semi-annual quickening also discloses itself directly in the cartouches. The previous semestral growth from the South Polar Cap actually showing in them before the impulse from the north began. The slow falling of their curves to the minimum preceding their latter rise is nothing less than the dying out of the effect started 6 months before from the south. The gentler gradient of their fall proclaims a gradual lapse, just as the subsequent sharper rise points to the advent of a fresh impulse. and this deduction seems to be borne out by another circumstance. There is some evidence of the decrease in the pre-minimal gradient southward. This is telling testimony to the source whence the impulse came. For if it originated at the south and traveled northward, the southern canals would be the first to be affected and the first to die out, and thus show a longer dead season, exhibited in the cartouches as a more level stretch. Lastly, the explanation of the canals as threads of vegetation phase in with the one which has been found to meet the requirements of the blue-green areas. While the fact that they prove to develop as they do, reversely to what would take place on Earth, is exactly what all we have latterly learnt about the surface conditions of the planet would lead us to expect. From what has just been said, we see that the latest observations at Flagstaff confirm the earlier ones, and, what is especially corroborative, they do so along another line. The former were chiefly static, the latter kinematic. In other words, the behavior of the canals in action bears out the testimony of their appearance at rest. End of Section 30. Recording by Michael Knowles, Fort Worth, Texas. Section 31 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit Librivox.org. Recording by Michael Knowles, Fort Worth, Texas. Mars and its Canals by Percival Lowell, Chapter 29, Life. Study of the fundamental features of Martian topography has disclosed, as we have seen, the existence of vegetation on the planet as the only rational explanation of the markings there, considered not simply on the score of their appearance momentarily, but judged by the changes that appearance undergoes at successive seasons of the Martian year. Thus, we are assured that plant life exists on the planet. We are made aware of the fact in more ways than one, but most unanswerably for that trait to which vegetation owes its very name, its periodic quickening to life. Thus, the characteristic which has seemed here most distinctive of this phase of the organic, so that man even christened it in accordance, has proved equally telltale there. Important as a conclusion, this is no less pregnant as a premise. For the assurance that plant life exists on Mars leads to a further step in extra-mundane acquaintance of far-reaching import. It introduces us at once to the probability of life there of a higher and more immediately appealing kind, not with the vagueness of general analogy, but with the definitiveness of specific deduction. For the presence of a flora is itself ground for suspecting a fauna. Of a bond connecting the two, we get our first hint the moment we look inquiringly into the world about us, that of our own Earth. Common experience witnesses to a coexistence which grows curious and compelling as we consider it, for it is not confined to life of any special order, but extends through the whole range of organisms of both kinds from the lowest to the highest. Algae and Monera, orchid and mammal occur side by side and with a certain considerate poverty or richness as the case may be. Luxuriance in the one is matched by abundance in the other, while a scanty flora means a poor fauna. This, of which we have been aware in regions round about us from childhood, grows in universality as we explore. Wherever man penetrates out of his proper sphere, he finds the same dual possession of the land or the sea, and a similar curtailing or expanding of both tenantries together. No mountaintop so cold but that if it grows plants, it supports insects and animals too after its kind. No desert so arid but that creeping things find it as possible a habitat as life that does not stir. Even in almost boiling geysers, animalcula and confervae share and share alike. Only where extreme conditions preclude the one do they equally debar the other. Proceeding now from the fact to its factors, we perceive reasons for this tenure in common of the land by the vegetal and animal kingdoms. Examination proves the two great divisions of the organic to be inextricably connected. It strikes our notice first in the relation of plants to animals. It is of everyday notoriety that animals eat plants, though it is less universally understood that in the ultimate they exist on nothing else. Plants furnish the food of animals, not as a matter of partial preference, but of fundamental necessity. For the plant is the indispensable intermediary in the process of metabolism. Without plants, animals would soon cease to exist, since they are unable to manufacture their own plasm out of the raw material offered by inorganic nature. They must make it out of the already prepared plasm of plants, or out of other animals who have made it from plants. So that in the end, it all comes back to plant production. The plant is able to build its plasm out of chemical substances. The animal cannot, except in the case of the nitrobacteria, begin thus at the lowest rung of the elementary ladder. But the converse of this dependence is also largely true. Plants are beholden to animals for processes that, in return, make their own life possible. The latter minister to the former with unconscious service all the time, and with no more arrogant independence than do our domestics generally nowadays. The inconspicuous earthworm is the field hand of nature's crops, who gets his own living by making theirs. Without this day and night laborer, the soil, for want of stirring, had remained less capable of grass. Above ground, it is the same story. Deprived of the ministrations of insects, many kinds of plants would incontinently perish. By the solicited visits of bees and other hymenoptera, what generally may be classed by the layman as flutterbies, is the plant's propagation made possible. Peculiarly well named indeed are the hymenoptera, seeing that they are the great matrimonial go-betweens, carrying pollen from one individual to another, and thus uniting what otherwise could not meet. Spectacular as this widespread commerce is, it forms but portion of the daily drama in which animals and plants alike take part. From forthright bargainings of honey for help, we pass to the less discreet but no less effective alliance where plants are beholden to animals for life by the killing of their enemies or by the weeding out of their competitors, and from this to generic furtherance where the interdependence becomes more broadcast. In the matter of metabolism, the advantage is not all on one side. In the catabolic process of that which each discards, are these two classes mutually complementary, the waste of the one being the want of the other, carbonic acid being given off by the animal, oxygen by the plant. In biologic economy, it is daily more demonstrable that both are necessary constituents for an advancing whole, and that each pays for what it gets by what it gives in return. That they are thus ancillary as well as coexistent today leads us to confront for them a community of origin in the past, and further study confirms the inference. Both paleontology and entomology, or the science of the aged and the science of the young, prove such ancestry to be a fact. By going back from the present into the past, or what amounts to substantially the same thing, by descending in the scale of life to the lowest known forms of organism, we find proof of concomitance, cogent because congenital. At the time when inorganic chemical compounds first passed by evolution into organic ones, the change was of so general a character that even such tardy representatives of it as survive today tax erudition to tell to which of the two great kingdoms they belong, the vegetal or the animal. Simplest and most primitive of known organisms are the chromacae, unnucleated single cells as Haeckel has shown, and next to them in order come many of the bacteria, also of simple unnucleated plasm. So little do the majority of bacteria differ morphographically from the chromacae that on the score of structure the two are not to be catalogued apart. Both are as elemental as anything well can be, which only their diet serves to divide. Each is an organism without organs, thus belying the dictionary definition of both animals and plants. Etymologically, they are not organic, yet manifestly they are alive, and only in their action are unlike. The chromacae are plasm-forming beings, and therefore they are plants. The bacteria are plasm-eating beings, and so are animals. Even this distinction is not always preserved. As Haeckel tells us, the nitrobacteria, which dwell in the earth, having the vegetal property of converting ammonia by oxidation into nitrous acid, and this into nitric acid, using as their source of carbon the carbonic acid gas of the atmosphere. They feed, like the chromacae, on simple inorganic compounds. Here then we have, close to the threshold of organic life, unorganized organisms, roughly speaking, coeval and differing in a sense but little, either of them, from inorganic crystals. And yet, one is an animal, the other a plant. progenitors of the two great divisions of life. They were themselves concomitantly evolved, either side by side or as offshoots, both of a common stock. Now, if the ancestors of the two great kingdoms were thus simultaneously produced here, we are warranted in believing that they would similarly be produced elsewhere, given conditions suitably alike. In consequence, if we detect the presence of the one, we already have an argument for inferring the other. Not to complete our syllogism would be to flaunt a lack of logic in nature's face. Rationally viewed, then, the general problem of life in other worlds reduces itself to a question of conditions. Since certain physical results follow inevitably upon certain physical premises, if we can assure ourselves of the proper premises, we may look to nature for their conclusion. A priori, then, the possibility of life becomes one of habitat. If the environment be suitable, life will ensue. What makes for such a mediary milieu is, like most cosmic processes, in its fundamentals of interesting simplicity. For the production of a proper nidus depends primarily upon the mere size of the body parentally concerned. If a planet be big enough, it will inevitably bring forth life, because of conditions suitable to its generating. If too small, it will remain sterile to the end of time. That size should be the determining factor whether a planet shall be fecund or barren may seem at first thought strange. Yet that it is so admits of no rational doubt. All that we see of bodies about us shows its truth, and what we have learnt of cosmic process enables us in some sort to discern why. In order for evolution, such as we mark it upon Earth, to be possible, the parent body must have been at one time at a high temperature, since only under great heat can the primal processes occur. But for this generation of caloric, the aggregate mass of the particles, the falling together of which makes the planet, and their stoppage its internal heat, must be large. The sun's rays alone are insufficient to cause the necessary temperature. The heat must come from within, though it be helped from without. Even here, the action is abetted by a large body. For a planet to entrap the sun's rays, or even to preserve its own internal warmth, an atmosphere is needed, and it takes a large body to retain an atmosphere covering sufficiently long. Yet without it, not only would there be no suitable state, but no medium in which organic or even inorganic reactions could go on. Lastly, water, the essential nidus for the organism's early stages, has its presence similarly conditioned. For this, like the atmosphere, would from a small body speedily vanish away. Thus, the planet itself is the life-producing body, although the sun furthers the process when once begun. That the needed substances are planetarily present, what we know of the distribution of matter astronomically sufficiently attests. What we find in meteorites shows that the catastrophe which preceded our present solar system's birth scattered its elemental constituents throughout its domain, and thus, when they came to be gathered up again into planets, that these must have been materially the same. The manner, not the matter, then, is alone that about which we are concerned. Now, if the mass of matter gravitating together to form a planet be sufficient to produce the proper inorganic conditions, the organic must follow as a matter of course. That the organic springs from the inorganic is not only shown by what has taken place on Earth, but is the necessary logical deduction from its decay back into the inorganic again. As Knowles admirably observes, the origin of the organic from the inorganic is, in the first place, not a question of experience and experiment, but a fact deduced from the law of constancy of matter and force. If all things in the material world are causally related, if all phenomena proceed on natural principles, organisms which are formed and decay into the same matter must have been derived originally from inorganic compounds. The original oneness of the two, the fact that the organic sprang from the inorganic, is shown by the cousinly closeness of the lowest organic with the highest inorganic substances. The Monera are suggestive of crystals in their uniformity of structure. Both are homogeneous, or approximately so. Again, Both grow by taking from what they come in contact with that which they find suitable, and so add to their body by homogeneous accretion. Finally, when grown too large for single life, they part into similar crystals or split into identical cells. The difference between the division of the crystal and the fission of the cell is small in kind, much less than that later differentiation in genesis into parthenogenesis and sexual reproduction. Yet here we unhesitatingly trace an assured relationship. It were straining at a gnat to swallow a camel to doubt it in the other. Just as the two behave analogically alike in their own action, so do they observe like an attitude toward nature. They thus point to their common origin. The Monera are resemblant of chemical compounds in their superiority to external influences. To outward conditions of temperature and humidity, the Chromacae are much as sticks and stones. Some species may remain for long frozen in ice, Haeckel observes, and yet wake to activity so soon as it thaws. Others may be completely desiccated, and then resume their life when put in water after a lapse of several years. Thus, both in their death-like lives and in their living immortality, the Chromacae are close to inorganic things. From preference, however, these lowest forms of life affect what to us would be unbearable temperatures. Many of the Chromacae live in hot springs at temperatures of 123 to 176 degrees Fahrenheit, in which no other, that is, no higher organism can dwell. This choice of habitat is in line with the other details of their evolutionary career, for it too is in keeping with the conditions of crystalline growth, halfway, as it were, on the road to them, the forming of crystals beginning at a temperature higher still, and we perceive from it that the passing of the inorganic into the organic is brought about by a lowering of the temperature of the parent planet. This again is in line with the evolution of chemical complexity. Let the heat become less, and higher chemical compounds, finally the organic ones, become possible. That evolution is nothing else than such a gradually increasing chemical synthesis is forced on one by study of the facts. Once started, life, as paleontology shows, develops along both the floral and the faunal lines side by side, taking on complexity with time. It begins so soon as secular cooling has condensed water vapor to its liquid state, Chromacae and Confervae coming into being high up towards the boiling point. Then, with lowering temperature, comes seaweeds and rhizopods, then the land plants and the lunged vertebrates. Hand in hand, the fauna and flora climb to more intricate perfecting, life rising as temperature lowers. We perceive then that, considered a priori, the possibility of life on a planet is merely a question of the planet's size, and then pursuantly that the character of that life is a matter of the planet's age. But age again is a question of size. For the smaller the mass, the quicker the body cools, and with a planet, growing cold means growing old. Within the bounds that make life possible, the smaller the body, the quicker it ages and the more advanced its denizens must be. Just how far the advance goes, we may not assert dogmatically in a given case, since not relative age alone, but absolute time as well, is concerned in it. It may be that nature's processes cannot be hurried, and that for want of time, development may be in part missed. But from general considerations, the limit of the time needed seems well within most planetary careers. Now, the aspect of the surface of Mars shows that both these conditions have been fulfilled. Mars is large enough to have begotten vegetation and small enough to be already old. All that we know of the physical state of the planet points to the possibility of both vegetal and animal life existing there, and furthermore, that this life should be of a relatively high order is possible. Nothing contradicts this, and the observations of the last 10 years have rendered the conclusion then advanced only the more conclusive. Even the evidence of the past state of the planet confirms that given by its present one. That with us, life came out of the seas finds its possible parallel in the fact that seas seemed once to have existed there, leaving their mark discernibly today. Life, then, had there, as here, the wherewith to begin. That we find air and water in both shows that it had the means to continue once begun. That it then ran a like course is further witnessed by what we now detect. The necessary premises then are there. More than this, one half of the conclusion, vegetal life, gives evidence of itself. End of section 31. Recording by Michael Knowles, Fort Worth, Texas.
Section 32 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kevin Brown, Bloomfield, New Jersey. Mars and its Canals by Percival Lowell. Chapter 30, Evidence. Of the existence of animal life upon a far planet, any evidence must, of necessity, assume a different guise from what its flora would present. Plant life should be, as on Mars we perceive it is, recognizable as part and parcel of the main features of the planet's face. In no such forthright manner could we expect an animal revelation. The sort of testimony which would render the one patent would leave the other obstinately hid. So long as animate life was in the lowest sense animal, it would not be seen at all, though it were as widespread as the vegetal life all about it. Reason for this lies in their receptive character. Plants are fixtures. Where they start, they stay. While from the nature of their food, derived directly from the soil and from the air, and conditioned chiefly by warmth and moisture, like forms inhabit large areas and by their massed effect make far impression. With animals it is otherwise. They feed by forage, from beetle to buffalo, roaming the land for sustenance. Thus, both for paucity of number and from not abiding in one stay, they must escape notice at a distance such that as individuals they fail to show, to say nothing of the fact that the flora usually overtop the fauna, and so help to hide the latter while appearing itself distinct. Any far view of our earth gives instance of this. Seen from some panoramic height, forest and moorland lie patently outspread to view, yet imagination is taxed to believe them tenanted at all. Unless man have marred the landscape, not a sign appears of any living thing. One must be near indeed to note even such unusual sights as a herd of buffalo in the plains, or those immense flights of pigeons that in former years occurred like clouds darkening the air. From the standpoint of another planet, through any such direct showing animal existence would still remain unknown. Not until the creatures had reached a certain phase in evolution would their presence become perceptible, and not then directly, but by the results such presence brought to pass. Occupancy would be first evidenced by its imprint on the land, discernible thus initially not so much by the bodily as by the mind's eye. For not till the animal had learnt to dominate nature and fashion it to his needs and ends would his existence betray itself. By the transformation he wrought in the landscape would he be known. It is thus we should make our own far acquaintance, and by the disarrangement of nature first have inkling of man. That it is thus we should betray ourselves, a consideration of man's history will show. While he still remained of savage simplicity, a mere child of nature, he might come and go unmarked by an outsider, but so soon as he started in to possess the earth, his handicraft would reveal him. From the moment he bethought him to till the ground, he entered upon a course of world subjugation of which we cannot foresee the end, but he has already advanced far enough to give us an idea of the process. It began with agriculture. Deforestation, with its subsequent quartering of crops, signalized his acquisition of real estate. His impress at first was sporadic and irregular, and in so far followed that of nature itself, but as it advanced it took on a methodism of plan. Husbandry begot thrift, and augmented wants demanded an increasing return for toil, and to this desirable end systematization became a necessity. At the same time, gregariousness grew, and still further emphasized the need for economy of space and time. In part unconsciously, man learnt the laws that govern the expenditure of force and more consciously applied them. Geometry, unloosed of Euclid, became a part of everyday life as insidiously as Monsieur Giordano found that he had been talking prose. Regularity rules today to the lament of art. The railroad is straighter than the turnpike, as that is straighter than the trail. Communication is now too urgent in its demands to know anything but law and take other than the shortest path to its destination. Tillage has undergone a like rectification. To one used to the patchwork quilting of the crops in older lands, the methodical rectangles of the farms of the Great West are painfully exact. Yet it is more than probable that these material manifestations would be the first signs of intelligence to one considering the earth from far. Our towns would in all likelihood constitute the next, and lastly, the great arteries of travel that minister to their wants. Their scale, too, would render them the first objects to be observed. Farming, as now practiced in Kansas or Dakota, gives it a certain cosmical concern. Fields for miles turning in hue with the rhythm of the drilled should impress an eye, if armed with our appliances, many millions of miles away. Even now we should know ourselves cosmically by our geometrical designs. To interplanetary understanding it is this quality that would speak. Still more so will it tell as time goes on. As yet, we are but at the beginning of our subjugation of the globe. We have hardly explored it all, still less occupied it. When we do so, and space shall have become enhancedly precious, directness of purpose with economy of result will have partitioned so regularly the surface of the earth as to impart to it an artificiality of appearance, and it becomes one vast coordinated expanse subservient entirely to the wants of its possessors. Centers of population and lines of communication, with tillage carried on in the most economic way, to this it must come in the end. Nor is this outcome in any sense a circumstance accidental to the earth. It is an inevitable phase in the evolution of organisms. As the organism develops brain, it is able to circumvent the adversities of condition, and by overcoming more pronounced inhospitality of environment, not only to survive but spread. Evidence of this thought will be stamped more and more visibly upon the face of its habitat. On earth, for all our pride of intellect, we have not yet progressed very far from the lowly animal state that leaves no records of itself. It is only in the last 2 centuries that our self-registration upon our surroundings has been marked. With another planet, the like course must in all probability be pursued, and the older the life relatively to its habitat, the more its signs of occupation should show. Intelligence on other worlds could then only make its presence known by such material revelation, and the sign manuals of itself would appear more artificial in look as that life was high in rank. Given the certainty of plant life, such markings are what one would look to find. Criticism which refuses to credit detail of the sort because too bizarre to be true writes itself down as unacquainted with the character of the problem. For it is precisely such detail which should show if any evidence at all were forthcoming. If now we turn our inquiry to Mars, we shall be fairly startled at what its disk discloses. For we find ourselves confronted in the canals and oases by precisely the appearances a priori reasoning proves should show were the planet inhabited. Our abstract prognostications have taken concrete form. Here in these rectilineal lines and roundish spots, we have spread out our centers of effort and our lines of communication. For the oases are clearly ganglia to which the canals play the part of nerves. The strange geometricism, which proves inexplicable on any other hypothesis, now shows itself of the essence of the solution. The appearance of artificiality cast up at the phenomena in disproof vindicates itself as the vital point in the whole matter. Like the cachet of an architect, it is the thing about the building that established the authorship. Though the Earth and Mars agree in being planets, they differ constitutionally in several important respects. Even to us, the curious network that enshrouds the Martian disk suggests handicraft. It implies it much more when considered from a Martian standpoint. End of section 32. Recording by Kevin Brown, Bloomfield, New Jersey. Section 33 of Mars and its Canals. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kevin Brown. Mars and its Canals by Percival Lowell, Chapter 31, The Husbanding of Water. That the canals and oases are of artificial origin is thus suggested by their very look. When we come to go further and inquire into what may be their office in the planet's economy, we find that the idea, in addition to its general probability, now acquires particular support. For this we are indebted in part to study of their static aspect, but chiefly to what has been learnt of their kinematic action. Dearth of water is the key to their character. Water is very scarce on the planet. We know this by the absence of any bodies of it of any size upon the surface. So far as we can see, the only available water is what comes from the semi-annual melting at one or the other cap of the snow accumulated there during the previous winter. Beyond this there is none except for what may be present in the air. Now, water is absolutely essential to all forms of life. No organisms can exist without it. But as a planet ages, it loses its oceans, as has before been explained, and gradually its whole water supply. Life upon its surface is confronted by a growing scarcity of this essential to existence. For its fauna to survive, it must utilize all it can get. To this end, it would be obliged to put forth its chief endeavors, and the outcome of such work would result in a deformation of the disk indicative of its presence. Lines of communication for water purposes between the polar caps, on the one hand, and the centers of population, on the other, would be the artificial markings we should expect to perceive. Now, it is not a little startling that the semblance of just such signs of intelligent interference with nature is what we discern on the face of Mars, in the canals and oases. So dominant in its mien is the pencil-like directness of the canals as to be the trait that primarily strikes an unprejudiced observer who beholds this astounding system of lines under favorable definition for the first time, and its impressiveness only grows on him with the study of the phenomena. That they suggested rule and compass, Schiaparelli said of them long ago, without committing himself as to what they were. In perception the great observer was, as usual, quite right, and the better they are seen, the more they justify the statement. Punctilious in their precision, they outdo in method all attempts of freehand drawing to copy them. Often has the writer tried to represent the regularity he saw, only to draw and redraw his lines in vain. Nothing short of ruling them could have reproduced what the telescope revealed. Strange as their depiction may look in the drawings, the originals look stranger still. Indeed, that they should look unnatural when properly depicted is not unnatural if they are so in fact. For it is the geodetic precision which the lines exhibit that instantly stamps them to consciousness as artificial. The inference is so forthright as to be shared by those who have not seen them to the extent of instant denial of their objectivity. Drawings of them look too strange to be true. So skepticism imputes to the draftsman their artificial fashioning, not realizing that by so doing it bears unconscious witness to their character. For in order to disprove the deduction, it is driven to deny the fact. Now, the fact can look after itself and will be recognized in time. For that the lines are as I have stated is beyond doubt. Each return of the planet shows them more and more geometric as sights are bettered and training improves. Suggestive of design as their initial appearance is, the idea of artificiality receives further sanction from more careful consideration, even from a static point of view, on at least 8 counts. 1. Their straightness. 2. Their individually uniform size. 3. Their extreme tenuity. 4. The dual character of some of them. 5. Their position with regard to the planet's fundamental features. 6. Their relation to the oases. 7. The character of these spots. And finally, 8. The systematic networking by both canals and spots of the whole surface of the planet. Now, no natural phenomena within our knowledge show such regularity on such a scale upon any one of these 8 counts, a fortiori upon all. When one considers that these lines run for thousands of miles in an unswerving direction, as far relatively as from London to Bombay, and as far actually as from Boston to San Francisco, the inadequacy of natural explanation becomes glaring. These several counts become more expressive of design the farther one looks into them. Straightness upon a sphere means the following of an arc of a great circle. The lines, then, are arcs of great circles. Now, the great circle course is the shortest distance connecting 2 given points. The canals of Mars, then, practice this economy. They connect their terminals by the shortest, that is, other things equal, by the quickest and least wasteful path. Their preserving a uniform width throughout this distance is an equally unnatural feature for any natural action to exhibit, but a perfectly natural one for an unnatural agent. For means of communication, for whatever cause, would probably be fashioned of like countenance throughout. Their extreme tenuity is a third trait pointing to artificiality. Inasmuch as the narrower they are, the more probable is their construction by local intelligence. Even more inexplicable, except from intent, is their dual character. For them to parallel one another like the twin rails of a railway track seems quite beyond the powers of natural causation. Enigmatic indeed from a natural standpoint, they cease to be so enigmatic viewed from an artificial one, and this the more by reason of what has lately been learnt of the character of their distribution. That they are found most plentifully near the equator, where the latitudinal girth is greatest, and thence diminish in numbers to about latitude 60 degrees, where they disappear, and this is not relatively to the amount of surface, but actually, is very significant. It is quite incapable of natural explanation, and can only be accounted for on some theory of design such as lines of communication, or canals conducting water down the latitudes for distribution. So that this distribution of the doubles is in keeping with the law of development disclosed by the canals en masse. Channels and return channels the 2 lines of the pair may be, but about this we can at present posit nothing. The relation may be of still greater complexity, and we must carefully distinguish between surmise and deduction. The position of the canals with regard to the main features of the disk has a cogency of its own, an argument from time. The places from which the lines start and to which they go are such as to imply a dependence of the latter upon the former chronologically. The lines are logically superposed upon the natural features, not as if they had grown there, but as if they had been placed there for topographic cause. Those termini are used which we should ourselves select for stations of intercommunication. For the lines not only leave important geodetic points, but they travel directly to equally salient ones. The connection of the canals with the oases is no less telltale of intent. The spots are found only at junctions, clearly the seal and sanction of such rendezvous. Their relation to the canals that enter them bespeaks method and design. Centering single lines, they are enclosed by doubles, a disposition such as would be true did they hold a pivotal position in the planet's economy. The shape of the oases also suggests significance. Their form is round, a solid circle of shading of so deep a tone as to seem black, although undoubtedly in truth blue-green. Now, a circular area has this peculiar property that it encloses for a given length of perimeter the maximum of space. Any other area has a longer enclosing boundary for the surface enclosed. Considering each area to be made up of onion-like envelopes to an original core, each similar in shape to the kernel, we see that the property in question means that the average distance for points of the circular area from the center is less than the same distance for those of any other figure. This has immediate bearing on the possible fashioning of such areas, for sufficient intelligence in the fashioners would certainly lead to a construction where the greatest area could be attended to at the least expenditure of force. This would be where the distance to be traveled from the center to all of the desired points was on the average least, that is, the area would be round. But last and all-embracing in its import is the system which the canals form. Instead of running at haphazard, the canals are interconnected in a most remarkable manner. They seek centers instead of avoiding them. The centers are linked thus perfectly one with another, an arrangement which could not result from centers, whether of explosion or otherwise, which were themselves discrete. Furthermore, the system covers the whole surface of the planet, dark areas and light ones alike, a worldwide distribution which exceeds the bounds of natural possibility. Any force which could act longitudinally on such a scale must be limited latitudinally in its action, as witness the belts of Jupiter or the spots upon the sun. Rotational, climatic, or other physical cause could not fail of zonal expression. Yet these lines are grandly indifferent to such compelling influences. Finally, the system, after meshing the surface in its entirety, runs straight into the polar caps. It is, then, a system whose end and aim is the tapping of the snow cap for the water there semi-annually let loose, then to distribute it over the planet's face. Function of this very sort is evidenced by the look of the canals. Further study during the last 11 years as to their behavior leads to a like conclusion, while at the same time it goes much farther by revealing the action in the case. This action proves to be not only in accord with the theory, but interestingly explanatory of the process. In the first place, the canals have shown themselves, as they showed to Schiaparelli, to be seasonal phenomena. This negatives afresh the possibility of there being cracks. But furthermore, their seasonal behavior turns out to follow a law quite different from what we know on Earth, and betokens that they are indebted to the melting of the polar cap for their annual growth even more directly than to the sun, and that vegetation is the only thing that satisfactorily accounts for their conduct. But again, this is not all. Their time of quickening proceeds with singular uniformity down the disk, not only to, but across the equator. Now, this last fact has peculiar significance. So large are the planetary masses that no substance can resist the strains due to the cosmic forces acting on them to change their shape till it becomes one of stable equilibrium. Thus, a body of planetary size, if unrotating, becomes a sphere except for solar tidal deformation. If rotating, it takes on a spheroidal form exactly expressive, as far as observation goes, of the so-called centrifugal force at work. Mars presents such a figure, being flattened out to correspond to its axial rotation. Its surface, therefore, is in fluid equilibrium, or, in other words, a particle of liquid at any point of its surface at the present time would stay where it was, devoid of inclination to move elsewhere. Now, the water which quickens the verdure of the canals moves from the neighborhood of the pole down to the equator as the season advances. This it does, then, irrespective of gravity. No natural force propels it, and the inference is forthright and inevitable that it is artificially helped to its end. There seems to be no escape from this deduction. Water flows only downhill, and there is no such thing as downhill on a surface already in fluid equilibrium. A few canals might presumably be so situated that their flow could, by inequality of terrain, lie equator-ward, but not all. As we see on the earth, rivers flow impartially to all points of the compass, dependent only upon unevenness of the local surface conditions. Now, it is not in particular but by general consent that the canal system of Mars develops from pole to equator. From the respective times at which the minima take place, It appears that the canal quickening occupies 52 days, as evidenced by the successive vegetal darkenings to descend from latitude 72 degrees north to latitude 0 degrees, a journey of 2,650 miles. This gives for the water a speed of 51 miles a day, or 2.1 miles an hour. The rate of progression is remarkably uniform, and this abets the deduction as to assisted transference. The simple fact that it is carried from near the pole to the equator is sufficiently telltale of extrinsic aid, but the uniformity of the action increases its significance. But the fact is more unnatural yet. The growth pays no regard to the equator, but proceeds across it as if it did not exist into the planet's other hemisphere. Here is something still more telling than its travel to this point, for even if we suppose, for the sake of argument, that natural forces took the water down to the equator, their action must there be certainly reversed and the equator prove a deadline to pass which were impossible. End of section 33. Recording by Kevin Brown.
Section 34 of Mars and its Canals. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Larry Wilson. Mars and its Canals by Percival Lowell. Conclusion. That Mars is inhabited by beings of some sort or other, we may consider as certain as it is uncertain what those beings may be. The theory of the existence of intelligent life on Mars may be likened to the atomic theory in chemistry, in that in both we are led to the belief in units which we are alike unable to define. Both theories explain the facts in their respective fields, and are the only theories that do, while as to what an atom may resemble, we know as little as what a Martian may be like. But the behavior of chemic compounds points to the existence of atoms too small for us to see, and in the same way the aspect and behavior of the Martian markings implies the action of agents too far away to be made out. But though in neither case can we tell anything of the bodily form of its unit, we can in both predicate a good deal about their workings. Apart from the general fact of intelligence implied by the geometric character of their constructions, is the evidence as to the degree afforded by the cosmopolitan extent of the action. Girdling their globe and stretching from pole to pole, the Martian canal system not only embraces their whole world, but is an organized entity. Each canal joins another, which in turn connects with a third, and so on over the entire surface of the planet. This continuity of construction posits a community of interest. Now, when we consider that though not so large as the Earth, the world of Mars is one of 4,200 miles diameter, and therefore containing something like 212 million of square miles, the unity of the process acquires considerable significance. The supposed vast enterprises of the Earth look small beside it. None of them but become local in comparison, gigantic as they seem to us to be. The first thing that is forced on us, in conclusion, is the necessarily intelligent and non-bellicose character of the community which could thus act as a unit throughout its globe. War is a survival among us from savage times, and affects now chiefly the boyish and unthinking elements of the nation. The wisest realize that there are better ways for practicing heroism, and other and more certain ends of ensuring the survival of the fittest. But it is something the people outgrow. But whether they consciously practice peace or not, nature in its evolution eventually practices it for them. And after enough of the inhabitants of a globe have killed each other off, the remainder must find it more advantageous to work together for the common good. Whether increasing common sense or increasing necessity was the spur that drove the Martians to this eminently sagacious state, we cannot say. But it is certain that reached it they have, and equally certain that if they had not, they must all die. When a planet has attained the age of advancing decrepitude, and the remnant of its water supply resides simply in its polar caps, these can only be effectively tapped for the benefit of the inhabitants when Arctic and equatorial peoples are at one. Difference of policy on the question of the all-important water supply means nothing short of death. Isolated communities cannot there be sufficient unto themselves. They must combine to solidarity or perish. From the fact, therefore, that the reticulated canal system is an elaborate entity embracing the whole planet from one pole to the other, we have not only proof of the worldwide sagacity of its builders, but a very suggestive sidelight to the fact that only a universal necessity such as water could well be its underlying cause. Possessed of important bearing upon the possibility of life on Mars is the rather recent appreciation that the habitat of both plants and animals is conditioned not by the minimum nor by the mean temperatures of a locality, but by the maximum heat attained in the region. Not only is the minimum thermometric point no determinator of a deadline, but even a mean temperature does not measure organic capability. The reason for this is that the continuance of the species seems to depend solely upon the possibility of reproduction, and this in turn upon a suitable temperature at the critical period of the plant's or animal's career. Contrary to previous ideas on the subject, Merriam found this to be the case with the fauna of the San Francisco Peak region in northern Arizona. The region was peculiarly fitted for a test, because of rising boreal island life out of a subtropic sea of desert. It thus reproduced along its flanks the conditions of climates farther north, altitude taking the part of latitude, one succeeding another until at the top stood the Arctic zone. Merriam showed that the existence of life there was dependent solely upon a sufficiency of warmth at the breeding season. If that were enough, the animal or plant propagated its kind and held its foothold against adverse conditions during the rest of the year. This it did by living during its brief summer and then going into hibernation the balance of the time. Nature, in short, suspended its functions to a large extent for months altogether, enabling it to resurrect when the conditions turned. Hibernation proves thus to be a trait acquired by the organism in consequence of climatic conditions. Like all such, it can only be developed in time, since nature is incapable of abrupt transition. An animal suddenly transported from the tropic to a subtropic Arctic zone will perish because it has not yet learnt the trick of winter sleeping. While still characterized by seasonal insomnia, it is incapable of storing its energies and biding its time. But given time enough to acquire the art, its existence is determined solely by the enjoyment of heat enough at some season to permit of the vital possibility of reproducing its kind. Diurnal shutting off of the heat affects the process but little, provided the fall be not below freezing at the hottest season. So much is shown by the fauna of our Arctic and subarctic zones, but still more pertinently to Mars by the zones of the San Francisco Peak region, since the thinner air of altitude, through which a greater amount of heat can radiate off, is there substituted for the thicker one of latitudinally equal isotherms. Here again, with the diurnal, as before with the seasonal, it is the maximum, not the mean, or, till low, even the minimum temperature that tells. Now with Mars the state of things is completely in accord with what is thus demanded for the existence of life. The Martian climate is one of extremes, where considerable heat treads on the heels of a great cold, and the one of these two conditions is as certain as the other, as the condition of the planet's surface shows conclusively. In summer and during the day it must be decidedly hot, certainly well above any possible freezing, a thinner air blanket actually increasing the amount of heat that reaches the surface, though affecting the length of time of its retention unfavorably. The maximum temperature, therefore, cannot be low. The minimum, of course, is, but as we have just seen, it is the maximum that regulates the possibility of life. In spite, therefore, of a winter probably longer and colder than our own, organic life is not in the least debarred from finding itself there. Indeed, the conditions appear to be such as to put a premium upon life of a high order. the Martian year being twice as long as our own, the summer there proportionately extended. Even in the southern hemisphere, the one where the summer is the shortest, it lasts for 158 days, while at the same latitudes our own is but 90 days. This lengthening of the period of reproduction cannot but have an elevating effect upon the organism, akin to the prolongation of childhood pointed out by John Fiske as playing so important a part in the evolution of the highest animals. Day and night, on the other hand, alternate there with approximately the same speed as here, and except for what is due to a thinner air covering, reproduce our own terrestrial diurnal conditions, which, as we saw, are not inimical to life. In this respect, then, Mars proves to be by no means so bad a habitat. It offers another example of how increasing knowledge widens the domain that life may occupy. Just as we have now found organic existence in abyssal depths of the sea, and in excessive degrees of both heat and cold, so do we find from exploration of our island mountains, which more than any other locality on earth facsimile the Martian surface, its possession there as well. Another point, too, is worth consideration. In an aging world where the conditions of life have grown more difficult, mentality must characterize more and more its beings in order for them to survive, and would in consequence tend to be evolved. To find therefore upon Mars highly intelligent life is what the planet's state would lead one to expect. To some people it may seem that the very strangeness of Martian life precludes for it an appeal to human interest. To me this is but a near-sighted view. The less the life there proves a counterpart of our earthly state of things, the more it fires fancy and piques inquiry as to what it be. We all have felt this impulse in our childhood, as our ancestors did before us, when they conjured goblins and spirits from the vasty void, and if our energy continue, we never cease to feel its force through life. But we exchange, as our years increase, the romance of fiction for the more thrilling romance of fact. As we grow older we demand reality, but so this requisite be fulfilled, the stranger the realization, the better we are pleased. Perhaps it is the more vivid imagination of youth that enables us all then to dispense with the hallmark of actuality upon our cherished visions. Perhaps a deeper sense of our own oneness with nature, as we get on, makes us insist upon getting the real thing. Whatever the reason be, certain it is that with the years a narration, no matter how enthralling, takes added hold of us for being true. But though we crave this solid foothold for our conceptions, we yield on that account no jot or tittle of our interest for the unexpected. Good reason we have for the allurement we feel toward what is least like us. For the wider the separation from the familiar, the greater the parallax the new affords for cosmic comprehension. That which differs little yields little to the knowledge already possessed. Just as a longer baseline gives us a better measure of the distance of the sun, so here the more diverse the aspects, the farther back they push the common starting point and furnish proportionately comprehensive insight into the course by which each came to be what it is. By studying others we learn about ourselves, and though from the remote we learn less easily, we eventually learn the more. Even on the side then that touches most men, the personal, the strangeness of the subject, should to the far-seeing prove all the greater magnet. One of the things that makes Mars of such transcendent interest to man is the foresight it affords of the course earthly evolution is to pursue. On our own world we are able only to study our present and our past. In Mars we are able to glimpse in some sort our future. Different as the course of life on the two planets undoubtedly has been, the one helps, however imperfectly, to better understanding of the other. Another, more abstract but no less alluring, appeals to that desire innate in man to know about the cosmos in which he forms a part, and which we call by the name of science. Study of Mars responds to this craving both directly by revelation of the secrets of another world, and indirectly by the bearing of what we thus learn upon our understanding of the laws of the universe. For the facts thus acquired broaden our conceptions in every branch of science. Some day our own geology, meteorology, and the rest will stand indebted to study of the planet Mars for advance along their respective lines. Already the most alert of those professing them are lending ear to information from this source, and such cosmopolitanism can but increase as the years roll on. Today what we already know is helping to comprehension of another world. In a not distant future we shall be repaid with interest, and what that other world shall have taught us will redound to a better knowledge of our own, and of that cosmos of which the two form part. End of section 34. End of Mars and its Canals by Percival Lowell.